directly from the experts. It's an honor to share this stage with distinguished experts from some of the most innovative and leading organizations, including Matsui Technologies India Limited, Kubota Brabender Technologies, 𝐒𝐲𝐶, 𝐿, a Troyster company, the Japan Steel Works Limited JSW, and Econ Machinery Private Limited. We are privileged to welcome you all to the Compounding Experts Meet 2024. Please give a big round of applause for each and everyone present over here.
Good afternoon, everyone. I am Vrunda Thakkar, and it's my Kalyanam. Shubham karotu Kalyanam. Shubham karotu Kalyanam. Thank you so much, everyone. Thank you so much. To officially kick off our event and set the tone for today's discussion, I am delighted to invite Mr. Tuhit Kataria to deliver the welcome remarks. Welcome, sir.
Ladies and gentlemen, good afternoon and welcome to the Compounding Expert Meet 2024, hosted by the Skills Engine Projects. It is a privilege to have you all here today, gathered from around the globe to exchange the insights and the innovations in the realm of compounding. We extend our sincere appreciation to our esteemed partners whose contributions have made this event possible. Matsui Technologie India Limited, Kubota Brabender Technologies, 𝐒𝐲𝐶, 𝐿, a Troyster company, the Japan Steel Works, JSW, and Econ Machinery Private Limited. Each of these organizations bring invaluable expertise and cutting-edge technology, and we look forward to the knowledge and perspective they will share throughout our time together. Today's gathering exemplifies the strength of the collaborations and the pursuit the excellence with our industry. We are privileged to have representatives from some of the world's leading companies, multinational companies, all dedicated to the advancement of the compounding technology. As we embark on this day of the presentations and discussion, I encourage you to engage actively, share your experience, and explore opportunity for the future collaborations. Together, we can foster innovation, address industry challenges, and pave the way for the sustained growth and the success in the compounding technology. Thank you for your presence and ongoing support and commitment to our shared objective. Let us seize this opportunity to learn, connect, and inspire one another. Thank you. Enjoy the event. Yeah.
Thank you, Mr. Tuhit Kataria, for warm and gracious welcome to the Compounding Expert Meet 2024. Now we are going to officially start our event.
Now moving right into our program, our first session today dives into the realm of innovative and sustainable material handling solutions for various extrusion and compounding lines. We are truly honored to have Mr. Afzal Beg, Deputy General Manager, Sales and Marketing at Matsui Technologies India Limited, to share his insight on this important topic. With over 22 years of experience in the polymer industry, Mr. Beg has handled key projects such as centralized drying and feeding systems, various industrial cooling solutions, and material handling systems. His extensive expertise makes him a valuable contributor to our discussion today. Please join me in welcoming a warm welcome to Afzal Beg.
Thank you. Good afternoon, everyone. I am excited to interact with you at this platform to learn each other. My topics to present here: innovative, sustainable material handling solution towards different extrusion compounding lines. So broadly, we cover company introduction. Product range, and our key achievement areas, especially PP with torque field lines and PVC compounding lines. So let me dive into presentation. Matsui, basically, it's a Japanese company, and in India, we are 50-50 joint venture company with Samvardhana Motherson Group. So that is Matsui Technologies India Limited is formation. Short form is MTIL. Then in 2018, we have another setup, tie-up with Frigel Italy company. So MTIL and Frigel Italy, though they have 50-50 joint venture company. So though we have Frigel Intelligence Cooling System, FICS. So presently we are operating in Noida, around 10,000 square meter capacity. So plant 1 is responsible for material handling and drying solutions. Plant 2 is for chillers and cooling systems. So this is our global network. Matsui have globally 7 operations, and globally they have presence at 63 locations. In India, we are operating from Noida. This is Matsui India global customer base. So we install around more than 54 countries. We are the ISO 50001 certified company. We are the CE certified company. So this is our playfield area. We are serving to Gulf countries, African countries, and SAARC countries from India only. This is our strength, like across our playfields, more than 1,200 customers we are serving. So this is the general setup of our products. We are silo feeding systems, and blenders. We have different range. So just a schematic diagram, feeding to the blenders with different materials, then feeding to the dryers, all metal separators. If any foreign particles having inside, then we can remove through all metal separators. Dehumidifiers we can dry, then feed to the injection blow molding or injection molding machines with the aero power hopper. That is patent design for Matsui. So it has automatically mixed if 2-3 components we are feeding to the receiver, then it will be mixed automatically and fed to the injection molding machines. Pointer is not working. Okay. Dosing systems for adding master batch or adding colors to your product. We have mold temperature controllers for different temperature ranges, 90 degrees centigrade up to 250 degrees centigrade. Chillers, package chillers, we are having mold humidifiers that is for if sweating is having on the mold, so we can remove the sweating through mold humidifiers and customized conveyors. This is our segment area. We are the leading supplier in automobile segments, packaging segments, extrusion segments, healthcare, rubber and tire industries, home appliances, and customized solutions. So further to bifurcate, we supply to compounding and pelletizing lines, wire and cables plants, PVC pipes and profiles. So this is our general schematic diagram for PVC pipes and profiles. So we have dumping stations with bag filters, then feeding, pressurized feeding to silos or vacuum feeding, both we are providing. PVC and calcium carbonate then feed to the wave hoppers. From wave hoppers that will automatically control through SCADA systems and transferred to the hot mixer, and it will be feeding to the cool mixer, then vibro screen for grading the resins, then feed to the RAVs and complete batch discharge to the recipe silos. Then we have coupling stations, automatic coupling stations as well as manual coupling stations, then feed to the extrusion lines, and we have line control systems to avoid any weight variation, especially for pipe industries. So this is one schematic diagram for PP torque field lines. So we have PP and torque fields. So bag hoppers, bag dumping hoppers, additives we need to feed. Then we feed up to the feeders. Feeders may be Kubota feeders or Brabender feeders. So we have the capability, and side feeding for any catalyst or agents, we will feed to the twin screw extruder. So this is our dumping station, jumbo bag loading by electrical hoist, and automatic bag dumping stations. So just for your understanding, one video is here. So bag compactor is along with them. So whenever the material removes, that bag will be collected in bag compactor. This is multi-component weighing hoppers. So Suppose the PVC compound, we need to be feed in a certain amount of desired percentage levels. Then calcium carbonates, if additive 1, we can feed additive 2, 3, 4, we can feed and then discharge to the hot mixer. We have the dense phase vessels. We can transfer the material in a batch or mass, wherever the mass transfer, then we can use the compressed air to transfer the material. We have the capability to manufacturing silos with different metals. So MS silos, we are manufacturing SS304 silos, aluminum, as well as dual structure inside SS304 and outer side is MS painted. That is called SS304 claddings. And we did like mezzanines as a turnkey solution. This is another line we did for PVC compounding line setups in Chennai. So there is combo bag dumping stations. Combo bag dumping stations here. So then we can transfer directly gravity fall to silos. Then calcium carbonate, we give pan feeders. Then transfer to the way hoppers. So PVC, suppose 40 to 60%, calcium carbonate is 15 to 20%. Then additives, from 2 additives, we will feed to the 2 different hoppers, then feed to the hot mixers with a certain temperature which we want to set in our panel, SCADA panels. Then stabilizer, we need to feed with certain amount of stabilizers as a binder to the hot mixer. Then it will be discharged to the cool mixers and it will be cooled down up to 50 degrees centigrade. Then discharged to the dry blend hoppers with the stirrer is there. It will rotate and then it is completely interlocked with the Brabender feeder bottom side on the knider. So if you can say here, there is diverter wall, cool mixer between dry blend hopper. Whenever is any rejection is there, so we can divert the dry blend, select to in diversion mode for diverter wall and collect the rejection in rejection bin. So same after palletizing, then we feed to the pallet hopper at right side. There is blower. Then it will comes to the pallet cooler with the completely interlocking systems. So from in between pallet hopper to pallet cooler, there is diverter wall. We can select the diverter wall for testing or rejection. If lot is rejected, then material is collecting in the testing bin downside. Then after checking, we can make it in auto mode and then it will goes to the pallet cooler. Below the pallet cooler, there is vibro feeders, then feed to the pallet storage hopper. Then there is diverter wall. Diverter wall basically feed to the one is going for jumbo bag filling station and another is going to the weighing station for 25 kg bag. It will wait and goes to the transfer in the bag. Then it will stitch and transferred to the main store area. So this is completely fully automatic SCADA systems we provide. So all sensors is controlled in a sequence through SCADA systems. So low-level sensors and all butterfly walls is mounted in the system, so all is controlled through the SCADA systems. So suppose we can feed the temperature or what we desire temperatures when we need to feed the material, another material. Suppose when in hot mixer temperature reaches up to 80 degrees centigrade, then stabilizer we need to be feed, then stabilizer walls will be open and feeding the stabilizers into the hot mixer. When batch temperature rises up to 120 degrees centigrade, then batch discharge to the cooling mixer. And in cooling mixer, when temperature is brings to lower down up to 50 degrees centigrade, then batch discharge to the dry blend hopper. This is our production management system. So recipe formulations, we can make the recipes or certain amounts like component 1, component 2, 3, 4, 5, we can make the recipes and saves in the list, and accordingly we can select from the recipe selection list and make it in auto mode without losing production time or no need for recalibration. Report management system, we can get the reports like batch weight, cycle time, or any feeding time. So complete reports we can generate and we can log onto the system or get print out or in pen drive. So this is like feeding to the silos from back dump stations. So we have the combo bag systems. So we can transfer the material, PVC and calcium carbonate to silos through a vacuum system that is around 1 ton per hour capacity systems. This is our jumbo bag debagging stations, bag dump stations. Here we give the interlocking with barcode panel to avoid any wrong feeding. So suppose there is 2 feedings, one is side feeding for 25 kg bag and top feeding for jumbo bag. So from barcode panels, we have the interlock in between. Wherever we selection, so wall will be open from the jumbo bag from top side, or lid will remains closed, or if top side remains closed, then lid we will make open. These are the PVC storage silos. So common silo is for 2 different lines with 2 different walls. The calcium carbonate silos with pen feeder or bin activators we can feed because it's sticky in nature. So is to be discharged. Then wave hoppers, we have different types of wave hoppers that is installed. Feed blower stations. Then we used diaphragm pump that is D-bump Italy make. So Normally, stabilizers is synthetic coils. So avoid fire hazards in the factory. We use diaphragm pump to feed the stabilizers to the hopper. These are the hot mixer assemblies, cooling mixer assemblies. So diverter wall is installing after cooling mixer. This is assembly for pellet processing line. So pellet cooler is pellet storage systems at top side. Then pellet cooler, pellet blower systems, then silos, so this is bag filling machines for 25 kg. It will stitch and transfer. So automatically it will also get the feedback how many bags is we can produce. These are the value-added components for compounding or powder conveying, material receivers, material diversion walls, central blower stations, spiral conveyors, lump crushers, and dosing dosers. Some feeders we have like MC line control systems, and adding the master batch. So another one is Matsui's main philosophy for factor 4, how to increase the wealth. We can say that double the profit with half resources. So we studied that how we can increase the production volume, how we can create the value, and whatever the resources we are using in the factory, how we can bring down to half level. Normally, we found that energy is wastage, resin wastage, water wastage, contaminations, foreign particles, dust formations. So we can control through our system. So these are 12 mantras. So for reducing resources, we can eliminate waste of energies, horizontal deployment, 3 to 9, that is production volume up. So how we can reduce the cycle time, reduction setup times, yellowing problem or rejection, control the rejections, elimination of color unevenness in the production, elimination of contaminations, water problems is having with the process, and how we can create the value, suppose dimensional accuracy if required in any parts. So we have the systems through rapid heating cooling systems, weight reduction if required with the same strength. So we have the systems, improve the surface qualities. That is the 12 basic mantras for MTI Matsui. So one of them is like how to improve the water quality. So that is a Frigel product, adiabatic cooler. It's the advanced replacement of cooling tower. So there is the application area. We can feed the water to air compressors, hydraulic machines, resin dryers, injection molding, PET preforms, extrusion lines, and blow moldings. We are capable to make chillers up to 200 TRs, air-cooled and water-cooled. So this is general schematic of adiabatic cooler or eco-dry. systems. So if you can see the bottom side, light blue color, this called adiabatic chamber, and in light blue color there is some sprinklers. They can feed little amount of water on the honeycomb pad that cools the air, then air will be get lift and coming to the contact with the heat exchangers that is made up of coppers, then it can be exchange the heat and making out. This is like different phases of eco-dry systems. So if -5 to 20 degrees centigrade, it means there is no energy consumption, fan remains off, and no water consumption. Everything system is working just as a circulation, pump is working. And if 20 to 30 degrees centigrade, then system is working in the dry mode. So if you can see the bottom side picture, so there is no water springs on the honeycomb pad, and fan is working according to the heat load. When we goes temperature high, 30 to 40 degrees centigrade, in that condition, adiabatic chambers is activated, and in that conditions, little amount of water is sprinkled on the honeycomb to cool down the air. Further, if ambient temperature is going high, so 40 to 45 degrees centigrade or above 40 degrees centigrade, in that case, booster mode is activated. So right hand side below pictures, if you have been, you saw here, so there is little amount of water spread on the heat exchangers to get temperature down. So our motive is to maintain desired temperature 34 degrees centigrade at any condition. So here is the video for your more understanding. So we have 95% water saving against cooling tower. Around 30% energy saving. If we can compare with the cooling tower, so of course investment cost is too high in first year, but if we can move ahead with the span of 3 years, then we found that cost will be reduced and ROI will be coming within 3 years, because there is water savings. Water, if you can see the blue color in cooling tower, there is huge water evaporation, energy consumption is huge, and other chemical additives or chemical treatments is required. But in case of eco-dry, it's negligible. Then we have the solution for scale formations. So suppose if passage or channels is blocked or scale is formed in the channels, so we have scale breaker to get clean that passage or channels. Eco pre-clear or 3-zone pre-clear, basically we used across the chillers or adiabatic cooler. That is completely closed loop circulation. Adiabatic cooler is the closed loop circulation system. So we connect across the adiabatic cooler or chillers. So normally we found that after certain interval of time, water will be destroyed and it will be yellowish, or we can destroy the water after some time. But if we connect the 3-zone pre-clear or eco pre-clear, we can recycle the water and avoid the wastage of water. Last but not least, PVC pipes and pulverizing systems. So we have pipe threaders, then feed to the granulators, pulverizing machines, then metal separator. We can separate out the metal particles, then we can collect in the pulverizing storage. So thanks for your engagement with us. Let me have any query. We can connect also in networking session. Our team is here. Okay, thank you.
Thank you, Mr. Beg, for your insightful presentation. We now have some time for question and answer. If anyone has any queries or would like to delve deeper into the topic, please feel free to ask. For any question, kindly raise your hands. Is anyone has any questions? Yeah.
Hello, I'm AP Shah. I would like to know that you give the whole unit as a package unit on turnkey basis? Any, say, compounding unit, say for PVC, if you are giving a compounding unit,
Yes.
all units are given by Matsui only, or you have some sub-suppliers?
We are mostly in conveying, and few like mixers we are not dealing, and few components we are outsourcing.
Okay, so can we get the list of those outsourced products which you are using?
Yeah, sure.
Yeah, okay, thank you.
Any more questions? Okay, thank you.
Our next session will focus on the benefits of gravimetric feeder and enhancing of feeding accuracy. We are pleased to welcome two esteemed speakers to the stage, Mr. Anup Biswas, the Manager in Charge India from Kubota Brabender Technologies, with an impressive 28 years of experience in the industry. Mr. Biswas has spent the last 17 years of focusing on Brabender feeder sales both in India and in overseas projects. His expertise extends across various sectors, including plastics, food, biopolymers, and battery industries. And our second speaker is Mr. Yagnaraman, the General Manager of Sales and Engineering at Kubota Boeki India Private Limited. With 8 years of dedicated service at Kubota Boeki, Mr. Yagnaraman is successfully handling the sales and services of gravimetric feeders, Kubota, other automation products. Together, they bring a wealth of experience and insights that will enrich our discussion today. Please join me in welcoming Mr. Anup Biswas and Mr. Yagnaraman as they share their expertise on this topic.
A very good afternoon, gentlemen, ladies and gentlemen. I would first like to thank SCP, the organizer, main organizer, and all the partners who have made this seminar possible, and all the guests. I welcome all the guests and the experts of plastic compounding industries for your presence to make the seminar a grand success. Your participation is highly appreciated. As SCP has already introduced me, I'm Anup, once again, from Kubota Brabender Technologie GmbH. And I'd like to invite our Kobayashi-san, the Global Sales Manager, Kubota Precision Weighing Division, Horigiri-san, Overseas Sales Manager of Kubota Precision Weighing Division, Shinkawa-san, who handles the Indian operation for Kubota business, and our channel partner, Yagnaraman is also here. And at last, I would like to invite our Manager Commissioning and Service, who is really very important for us because he does all the commissioning and services for our feeders. He is Mr. Mahesh Rawat. So this is our team where I would like to introduce that we are working as a team in India. Each one of your contribution can lead to a team's success in Indian market. I will now would like to go to my presentation. Thank you, gentlemen. You can take your seat. I will like to go, there are many queries in the mind of our customer that why do Kubota Corporation and Brabender Technologie joined hand together? Firstly, let me little bit brief what we do. There is no introduction required. Kubota Brabender Technologie is the leading manufacturer of gravimetric and volumetric feeding systems and discharging aids. Some of the aids which has been shown, like bean activators, and already shown by Mr. Beg, and bulk bag dischargers, bag dumpers, they are also in our scope. We come with 66 years of experience in the field. We have worldwide employees of 260 people. After we collaborated, we are now present globally in 6 locations. We have more than 53 channel partners. We have tested 14,000 raw materials in 40,000 applications. So this is how we look globally. Where we are situated, red balls means our offices are there, and all our channel partners are shown in sea green color. This is our international headquarters. It is the same headquarters where Brabender Technologie GmbH was situated. Now it is known as Kubota Brabender Technologie GmbH. A short history about our company. It started in 1923 by our founder, William Brabender. So that was known as Brabender Technologie, which came into existence in 1957. Then follow through, we had subsidiaries in Canada, Russia, China, Dubai, and in 2008, this Indian subsidiary was started. And we changed our legal form from Brabender Technologie 𝐾G to Brabender Technologie GmbH and Company 𝐾G in 2012. And we are known in this format, but in 2022, Kubota Corporation took over Brabender Technologie Germany, and we are now known as Kubota Brabender Technologie GmbH. A short history to even a bigger company, Gonshiro Kubota, the founder of Kubota Corporation. He founded this company in 1890, even before Brabender Technologie GmbH. And the capital investment, you can see, absolutely there is no comparison to our specifics. We are only 2,003 people globally when they took over, and they are 52,000 plus. That is the strength of the company, that is the strength of the people they work, it is in the market for so long. The headquarters of Kubota Corporation is in Japan, Osaka. And I included this slide. He is our current president, 𝐤𝐮𝐞𝐽. Why I included is I liked his brand statement. He promises to continue supporting the prosperous life of humans while protecting the environment of this beautiful earth. Doesn't it sound very good? Because it's not only for business, but for earth and for life. Kubota's statement is this. And so we are also the part of this Kubota group now. Mainly Kubota's business has two parts. One is with water and environment, and another is in the machinery division. Agricultural construction business, engine is in the machinery division. They are mainly known for that. And we also are a part of that part is weighing and measuring controlling systems. Kubota also has water pipeline. It is also a huge business for them, and environmental protection equipments and material. Now, the question comes in about why we integrated. We were direct competitors at some point of time. Now, it is not a hostile merger, it is a friendly horizontal merger. This is what I call. And why we wanted to consolidate this industry together, reduce competition. There are definitely certain resources and skills in everyone, so we wanted to enjoy that economies of scale and build up the synergies. And what advantage do the customer gets now? Under the same umbrella, under the same roof, you have both the brands together, Brabender Technologie as well as Kubota. And how we plan to do it in India. With my friend Yagnaraman M and Kyokuto Boiki, we have handshaked for our larger benefit, and this is how we look in India now. We were only in Calcutta before 2022. Now we are located in some areas like Chennai, where the headquarters of Kyokuto Boiki is. Ahmedabad, we have a service center, and Gurgaon, we also have a service center. Now, I quickly go into our product portfolio, what Kubota Brabender Technologie GmbH can offer you. We can supply, of course, without JSW extruder and SM Platek extruder, we can supply the entire thing. Okay, I had to drop it. We have to draw the line because somewhere around the corner we have to drop the material. So right from the bulk bag discharging, the back dumper, to the screw conveyor, to feeders, and then you have a liquid feeder also. Here, just sitting next to the extruder. So we are not manufacturer of extruder. This is where we can deliver your raw material. To be more specific, some of the examples are shown here. Single screw, twin screw, flex roll, fiber experts. This will be dealt by my channel partner, Mr. Yagnaraman M. He will show you some more specific things. We have laboratory equipments also, vibratory tray, liquid feeders, all form of liquid feeders. I mean, you can have a standard liquid feeder, you can have water heated version liquid feeder, you can have oil heated liquid feeder, you can have electrically heated liquid feeders also from us. And of course, what is more important is the certification. We are certified for ATEX, is explosion proof. UL is not required in Asia. So these are the certification that mostly we have for food, pharma, and all other things. This is our slogan from Brabender Technologie GmbH, keep the flow. I end my session So I believe I have not taken too much of time. So, any questions? चमोली जी, कोई क्वेश्चन नहीं है ना आपके पास? नो क्वेश्चंस? मोहन साहब, कोई नहीं है ना? कुछ क्वेश्चंस? Thank you. I may leave my space and give it to Yagnaraman sir.
Good evening to all the members gathered here. Thank you, SCP, for organizing this event and providing us an opportunity, and welcome all the industry people gathered here. It is a good opportunity for us to present our informations to all the members at one place. So thank you all for making your time to be here. And especially thank you, Anup San, for introducing each one of us. And as a channel partner, it is our next journey moving forward in handling both brands together and in the India market. So thank you. We hope we will move forward in a bigger place. So beginning with, as many people have been known, gravimetric feeder used in the compounding and other applications, we like to emphasize on very specific points which can be beneficial and to address the issues which has been faced in the premises and how it can be resolved. So we want to focus on these points, like why feeding accuracy is important in today's place, and how the materials with various characteristics can be handled. And there are some specific reasons which causes the feeding accuracy to be affected. One is material related, and next is the refill related, and how these can be prevented, and especially what our feeders can be do. So this is one of the example. Right now we are moving into the electrification. Many of the parts are getting changed according to the requirements as we are moving to the green energy, EV vehicles, like weight reduction due to the long driving range, etc. So metal to plastic conversion is one of the key aspects. In earlier days, we have limited raw materials used. So mostly in the batch process or pre-mixing and limited raw materials. But now, day to day, the R&D and new developments are happening rigorously, where n number of materials are being tried out, which needs precision feeding, where the gravimetric feeder plays a key role to achieve precise feeding. So this is the basic process. The advantage of gravimetry is all the process is measured, right from the material feed charge to the feeder and to the feed amount into the extruder and to the end produced amount. And the same wise, based on the feedback mechanism, we can generate the various alarms or drive histories and can detect the NG materials and protect from further wastage of materials. Why it is difficult? Because each material has its own characteristics and the feeders are same, but we need to have minor differences to handle each of them effectively, such as in some powders we have the rat hole and some has the low melting nature which may adhere to the screw area and which will cause the fill factor reduction and fiberization, which will form wool structure inside the hoppers. So to prevent these, what we can do? So we need to analyze the characteristics as we have structured here, starting from pellet granule which is free flowing, then comes the crushed material of various other natures and fibers. Next, powders, which has the wide range of characteristics from bridging, flushing, adherence and low melting. So we need to choose the right feeder to handle these different materials, and it's also to be capable to handle different materials when it is required in the future, because feeder cannot be changed frequently depending on the application. So the machines which are selected should be capable to handle different grade of materials. How we determine? We check on these 4 parameters: bulk density of the material, angle of repose to determine the bridging tendency of its, particle sizes to ensure the right tolerance between the screws, melting point to determine the maximum operating range of the screw to prevent heat generation within the feeder. Based on these 4 characteristics, we can select appropriate machines from the lineup ranging from screw feeders, single screw, twin screw, and then belt feeder, especially for pellets, vibratory type for the fiber materials, and liquid type for feeding liquid additives and other ingredients. Each model has its own advantages, considering the wide range of material handling to easy maintenance, cleaning, and multifunctionalities. Then we come down the reasons why it is getting affected. One is related to the materials. Different material have different bulk densities. Like whenever the refilling is happening, there is a change of material nature due to the air containing into it. So that is getting affected, and the refill rate, the pressure inside the hopper also gets changed, which also create an impact. And the inconsistent feeding due to the material adherence to the screw profile. So over a period of time, the fill factor got affected and the screw rate increases, causing effect in the feeding performance. And secondly, flowability. Refill devices has multiple applications which has to be rightly configured to enhance proper refilling. This is one of the examples when initially the hopper is full, the pressure is high and there is uniform flow, but as the material decreases, it creates a difference in pressure as the gravimetric feeder senses and increases the MV. This has to be rightly detected, which is the optimal range to start the refilling process, so that the MV is stable even during refilling, so overfeeding is not happening. This is highly available in the heavier bulk density material because the level will be low due to its bulk density nature. So improper feeding may possible. And this is a small video showing how the fluidic nature of material when comes in contact with air during the refilling process. So this has to be addressed to maintain the minimum pressure inside the hopper. Next is refilling. We go into detail. As we say, during the refilling operation, it starts at the lower limit of the feeder and ends at the upper limit. During this process, mostly the feeder rotates at the stable screw rotation based on the calculation it does prior to the refill start of operation. But this duration is very important because mostly it runs in the volumetric mode. If the number of refill interval is high, we may start a countermeasure to reduce the duration so that the number of refilling frequency will increase in a particular hour. This is also not good because even though the interval is small, but the number of frequencies are high. So the number of times it goes into the volumetric mode is also high. So what the next countermeasure we can do is, we need to ensure the right capacity of the refill device so that the number of times refilling happens in an hour should be around 10 to 15 times per hour, and the total interval for one cycle can be around 20 seconds. So in this case, we can reduce the time as well as reduce the frequency, maintaining the same refill volume. We need to ensure in case of heavier materials or light bulk density materials, it should not overfill the hopper volume. So this point has to be considered. Next, how we can prevent the errors. Even though we take care of all these concerns, there are some on-site works which has to be considered. Starting from installation times like levelness, flexible joints, air blowing and suction from downstream, wind, mounting frames and the material refill, especially for the development lines at this point. We have two types. One is frame mounted and then is the caster type depending on the requirements. So in this case, this is also key to ensure the level is stable to prevent weight effect in the load cell during refilling and continuous process. Flexible joint. There is various options available from anti-static cloth to silicone or various options. Still, we need to ensure the tension is at the minimum level so that there is no weight impact due to the flexible joint in the feeder. It comes in the two areas, one in the inlet and next in the outlet. So these are some examples where we have a vent to collect the pressure from the feeder, But if the vent pipe is connected with the inlet hopper, there is a possibility it can suck the inlet chute also, so which causes weight variation in the feeder. And this is how it should be, like the recommended distance is around 100 mm between the inlet pipe and the flexible joint, and when to be placed separately so that it doesn't connect together. It also has an effect in the extruder inlet hopper. When there are multiple ingredients feeding into the main hopper, there is a possibility of pressure creation inside the extruder inlet, where the light materials can, due to the back pressure, go back to the feeder inlet pipe. So we need to place separate vent in the extruder inlet hopper also to prevent this happening. It can even, depending on the feeder rate, it can even back pass to 4 meter lengths too. So this has to be focused. Next is effect of wind on the feeding. Wind is also one of the disturbance, directly affects the weight due to the load cell. So this is a small demonstration like how the weight can impact the weight value of the feeder. Because our industry structure is huge, there can be any source of wind either to the ventilation or the exhaust or even by the stairs area. So this has to be controlled. And vibration. This is one of the key effects occur in most of the facilities. Vibration is one of the major issues affect the weight value in the feeder. One, the feeder has to be isolated, or next, it can be mounted on the channel which can absorb much of the vibration. Even though feeder has some internal calculation to eliminate certain frequencies of vibration in order to maintain stable feeding. So these are some examples and some schematic. Even though isolation, if the support bracket is connected to the floor and to the heavier movement above the floor structure, which can also have an impact. Refilling. Refilling case also, this issue comes through the refill device, which has to be addressed. One is vibration when we use a circle feeder or vibration blower on top side for the refill device loading, and next is leakage. Let's take an operation of two feeders. Feeder 1 has smaller refills and feeder 2 has multiple refills, but we can see whenever there is a refill operation happening in feeder 1, because of the vibration caused by the refill device in feeder 1 affects the performance of the feeder 2. As each line will be installed with different ranges of feeders which has a different load cell resolutions, so the polymer feeders operation may affect the additive feeders operation indirectly in this way. And next will be the leakage of material from the refill device. We use different type of refill device depending on the material. So if there is any seal issues or improper selection of refill device, there is a possibility of leakage, which may cause continuous weight value variation in the feeder as the material comes in a slow manner, but even a gram matters. So in this case, the feed rate will be varying irrespective of the condition. This, in continuous production, we will be mostly using the automatic refill devices and silos and necessary operations. Mostly in the lab lines, we will be conducting the manual charging depending on the smaller batch volumes. So in these cases, the operator needs to charge the material depending on the requirements in the same platform, which might cause vibration or other weight effect. So in this case, it is better to have some manual lock switch so that the feeder goes into the lock mode in advance prior to the operator movement. So these small remedies can prevent the feeder from improper feeding. So these are the external factors which can affect the performance of gravimetric feeders. Whereas next to the selection of feeders, these are the other factors which has to be considered to ensure the proper result of feeders. Next, what our feeders can really do. We are here to explain, since we become one company, we can explain about both the brands to all of them. So first with Kubota NX series. We call this as unique feeder to handle multiple materials ranging from pellets, powders, or premix or glass fibers, etc. with different screw profiles. This design of the screw ensures there is very less material adherence to the screw profile, and it provides versatility to the user to interchange and feed different materials according to their requirement. Apart from the screw profile, the key aspect is the feeder design. We call this a negative wall angle, which releases the pressure in the lower hopper and allows the smooth flow of material. You can say as an anti-bridging design. With this agitation movement, even the difficult powders can be handled without any issues. And the agitator is placed diagonally around a 45-degree slittle structure, which slides close to the hopper wall and moves the material to the screw area, providing high fill factor. So with this, we are able to have little effect or a negative effect on the weighing scale and achieve a high feeding accuracy. Next, we have the fiber expert. It is specially developed to handle the fibers. As the new market develops, we have a requirement of feeding new ingredients ranging from carbon fiber or natural fibers or recycled PET flakes, etc., which the standard conventional feeder has a lot of difficulties to handle. So in this case, the fiber expert can handle with efficient feeding with a special design. You can handle such carbon fibers in a higher output also. So what strength we have to the industry? With combining both the brands, we have integration with weighing, powder handling and controls. Especially, as you know, Kubota is not only a feeder manufacturer, they are the first to develop the digital load cell in the Japan market, and we have more than, this is our 100th anniversary in the weighing division. So we have vast history and data technology know-how on the load cells, and we are also the OAML regulated manufacturer for the load cells. Powder handling, we have vast test reports. We have a technical center in Japan, Korea, and in India and Germany. So we have a vast history of test records, which can be helpful to propose the right equipment to the customers. Control, we have dedicated control algorithm and much auto detection function to analyze the site requirements and adjust the feeding functionalities. So thank you everyone for giving your time.
Thank you, Mr. Biswas and Mr. Yagnaraman, for your insightful discussion. Now we again have a time for question and answer. Is anyone has any questions?
Hello. Yeah, I'm Dr. Shukla, and I just want to know, you mentioned about fibers. So aramid fibers or carbon fibers, what is the accuracy level of your feeder? Plus minus 1%. Yes, and if we...
Our main purpose is that inside the feeder, the fiber should not get crushed, and it should not form an wool type structures. Then it will be very difficult to feed.
That was my another question, how to ensure that?
Yeah, this is because of the special design of our screw. If you have, yes, my Yagnaraman son has shown you this type of screw.
Yes.
If you see that it has a trapezoidal pipe type in the back side, and in the front you will see that it's a spiral type of screw. So our main purpose is that the material should flow from back end to the front end, to the discharge tube. So the more the material you have in the front end, the material will get flowed easily, and it is a single screw feeder.
Right.
Okay, there is no chance of crushing inside. And at the back, you will have lower volume of material because of that pipe. Right. So this is a special design, proprietary design of Brabender.
And if I want to feed two different fibers simultaneously, is it possible? With two different feeders?
Yeah, of course possible. Of course possible.
Okay.
Because you need, our controller will designate one feeder, first feeder as a feeder 1, second feeder as feeder 2, like that way. You can program your thing in the controller.
Dr. Rahul Shingte, I represent ScienceCo. I have a question linked with Dr. Shukla's question. He was talking about aramid fibers. And if you have any specific feeder for aramid fibers with a technical note, maybe we can discuss during the break. Because if you can throw some light during your answer session now.
Yeah, this is our colleague Mahesh has a video of this feeder is known as Fiber Expert. It is not used for any polymer or powder. This we have developed only for fibers. Only for fibers.
Aramid fibers, because this is slightly different than the normal fibers what you have shown here, not the carbon fiber.
Probably it will be exaggerated. It is better that we can have some sample, and maybe we need to test it in our test lab to really propose the correct feeder, because you need the correct screw profile for that. We have a test lab in Germany, sir. And as well as you can, we have office in Calcutta. If you can send us the sample, we can organize to send it to Japan, because in Japan also we have one model of this fiber experts, as well as in Germany.
Yes, our main concern is to, maintain the accuracy.
Exactly, because our the screw profile, the screw design will depend on the kind of material you want to fit.
And not only that, the diameter of the fiber, size of the fiber will vary.
Yeah,
so every time
that is, if you can give us the worst possible kind of ingredient,
right,
then we can test it and we can come up with the solution for you.
Thank you. Yeah.
Okay.
Just a curiosity.
In that, 1 minute.
Hello.
Sir, I beg to differ here. The point is, as you know, this compounding using fiber, that too particularly long fibers, are quite new. Quite new globally. It is very new, very new applications are coming up with the longer threads of fibers and things. So we have been advised by our headquarters that it is better that you get the sample from the customer so that we can select, we can suggest the best feeder. It can be so. It can be so that you don't need the fiber expert that Yagnaraman San has shown you. Our flexual feeders also do have very good, the usage. I believe everyone, our European partners, they know our flexual feeders, and we feed fibers to them, but there is a limitation. 5 to 6 mm is the maximum length. But here, if you see to the fiber expert, you can go up to 15 mm also for certain kinds of grades of carbon. Yeah, that is the reason.
I have only one question. Because of the change in the dimension, as Dr. Shukla said, you will also have the change in the diameter of the fibers also, not only the length. So whether your screw feeders has a variable frequency drive or it's a constant speed?
Of course it is depending on variable frequency drive. We have frequency converters for all the feeders run on frequency converters.
Okay.
So it is on VFD. Otherwise your loss in weight principle will not work. Gravimetric feeder will not work.
Thank you.
I have one question. We are utilizing Brabender.
Sorry, I couldn't.
Sir, we are utilizing Brabender feeders.
Okay.
Having the analog load cell as well as digital load cells.
Yes.
Is there any service center in India for repairing of the digital load cell? Only option is that for replacement or any repairing possibilities there?
Repairing possibility is very negligible in case of load cells. This is, if there is a small, repair, this can be better answered by my commissioning manager. Mahesh, if you can answer, which are the parts that we can repair in India itself, but usually load cells are not repairable.
Okay.
Yeah.
Good evening, all ladies and gentlemen. Myself, Nanu Vade from Astra Specialty Compound India Private Limited. Especially Brabender feeder, which screw design you have for a typical material like a titanium dioxide and premixing? Normally we are using the spiral single screw, yeah? Yes. So you have any other designs for reducing the scaling and also the mass flow variation like that?
For me, as far my experience goes, the best feeder for titanium dioxide is flex-valve feeder with 2 motors. Separate motor for paddle and screw. Second thing is, titanium dioxide powder is, as you said, it has a slow moving and it sticks to the screw. Spiral screw is the best feeder for that screw, product. But we can increase the reinforcement, the strength of the screw by having a core, center core, which will join the shaft with the discharge point, and there will be welded plates in that screw.
Yes, so that's why I told you what the screw design you have for that. So that's why we have some screws, we have spiral, single, what you discuss about. Yeah. So I have all these things. We are also enforcing paddle screw 2 motor also. So just I want to know what screw you have, so we are reducing the scaling of TiO2,
Look,
screw design only. Which screw design you have?
Scaling of TiO2 is only, you cannot do away 100%.
Yeah, I know, but we can reduce of a screw design.
The only thing which we can do is we can increase the reinforcement in the screw so that it reduces the damage of the screw. But if with my so many years of experience, if I make a commitment that 100% it will be, your deposition will not be there, I'll be wrong.
Its small capacity is okay, but when we are going into high capacity,
then it is better.
Then we are facing.
Yeah, then it is better to go with twin screw.
In Brabender, in Brabender,
yeah.
You have the twin screw up solid or the spiral?
You can have solid screw. You can have spiral screw. You have all options available. Brabender.
Okay, thank you.
Thank you. Yagnaraman.
Hello, sir. So I am 𝐿𝐿. I'm from Matsui, basically. I have a question. How is this fiber blending solution is effective? Your fiber blending technology for this natural fiber, such as banana fiber, actually, Because these are actually, you know, low denser actually, because more variation is there in that. Can you please, you know,
Look,
give?
if you go with this such low bulk density material,
Yes, sir.
my suggestion will be flexual feeders. Flexual feeders will be the best solution with a blade screw, single blade screw.
Okay.
That will be the best solution for such kind of
Flakes and fiber.
Look, firstly, I have to correct your point. It is not a blender; it is a feeder. Huh?
Okay.
Okay.
Yeah.
When we talk about the blender, means you will mix, but it's a feeder.
Yeah, it's a feeder.
So
Yeah.
purpose of the feeder is to feed the ingredient to your process.
Yes, sir.
Okay. Now, what can be the best feeder? Based on that material characteristics, we can offer you the solution.
Okay.
Okay.
But the thing is that in these natural fibers, they do actually have certain problems such as the static energy and maybe, you know, degrading in this process also. Does there is any solution actually for this? Okay.
I have already pointed it out.
Okay.
Our primary purpose as Kubota, Brabender Technologie, both of us, we maintain one thing, that there should not be any degradation of the material in our feeder. So we propose you the solution in that manner that whatever is the ingredient characteristics that is in the inlet will get it out. So we have so many varieties of screw feeder types. You can have a single screw feeder, you can have twin screw feeder, you can have flexual feeder, you can have NX feeder. Okay, you have seen the advantages of the NX feeder also. So these are proposed based on the ingredient characteristics, selected on the based on the ingredient characteristics. Even we have built feeders. We have hybrid tray feeders. It is not that exactly every time, I mean, since I am in this industry, I know we have competition where my competitor only proposes hybrid tray feeder for 5 years. But I have had a very bad experience from my last assignment with the vibrated tray feeder, when it is a feeder with a fiber with a length of more than 3 mm will create problem at the bottom of the discharge of the just above the tray.
During my actually college days, actually I faced this problem. That is why
face it. So you know better. Yeah. Because I'm in this field for 28 years. That is, madam, I have shown it. So I have practical experience of that. We have even tried. Okay. We have even tried with putting a mechanical comb.
Yeah.
We have tried
manually,
it with put it.
Manually we did the combing.
Whenever we do it, it discharges on the tray, but then it is imbalancing. It is imbalancing.
Density variation is there.
Yes. You have a lump. You have a wool.
Yeah, exactly. In that composite, actually, you will have a density variation.
Yes. Yeah. Yes.
Yes, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Hello. I think now there are some questions the people need to ask. So let's take a tea break. So now it's time for refreshment. Enjoy a coffee break and take this opportunity to connect and network with the fellow attendees and experts. We will be starting our third session soon. We'll gather again shortly to continue with the program. Thank you so much.
these good vibrations. Have you ever felt the sunset? It's full of hope and answers. Let yourself go free and be drawn into these good vibrations. Everything you want is right in front of you. Everything that you can give will only be returned to you. Have you ever felt the sunset? It's full of hope and answers. Let yourself go free and be drawn into these good vibrations. There is nothing here. It's not in constant change. Constant change. This can comes with something. But daylight comes tonight. Nighttime. Into this good vibration.
Ladies and gentlemen, we hope you enjoyed the tea break. Kindly be informed that we will be resuming our event in 5 minutes. Please make your way back to your seats as we prepare to continue the insightful discussion and presentation. Thank you for your cooperation. Hello. Hello. I would like to request everyone to kindly take your seat as we are going to start our session in 5 minutes. Welcome back. I hope everyone is returning with excitement and had a chance to connect our experts during the break. Hello. Everyone kindly please take your seats. In the last row, sir, kindly take your seats. So we have placed our feedback forms on each table. Kindly fill it up and our team will be collected after the last session. We have surprise gifts for 3 lucky winners. Everybody please pay attention on rules for the surprise gift. First rule is one person can submit only one form. Second, the form must be fully filled it out. Third, the participants should write their confirmation number on the form. Kindly listen, you should write your confirmation number on the feedback form. And the last, the participants must be present in the ballroom during the draw, otherwise we will select another lucky person. We will announce this lucky draw after the last session, so kindly fill it your form after the last session. Thank you so much.
Our third session will explore mixing solutions for engineering and plastic cable compounds. We are pleased to welcome Mr. Andreas Beckers, Sales Manager from 𝐒𝐲𝐶 with over 30 years of experience in the plastic industry. Mr. Beckers brings a wealth of knowledge, particularly in the field of gravimetric systems and ultrasonic measurement technology for plastic applications. His insight will provide a valuable perspective on our important topic today. Please join me in welcoming Mr. Andreas Beckers.
Thank you. Thank you very much for the warm words. I also would like to welcome you here at the SAP event. And first of all, I would give a big and great thanks to the SAP and the team to realize this event and this today. And I also would like to give a big thank you to the partners which also participate here during this day. And finally, a great thankful to the audience that you will participate here, that you will take your time here to listen to what we can introduce you here for your application. So, I would like to start. As mentioned, I want to speak about the possibility of state-of-the-art mixing technology for the compounding process, for cable compounds, engineering compounds. And I want to start with a short introduction of the 𝐒𝐲𝐶 company itself. Furthermore, I would like to give some basic information about mixing itself. What does it mean? Which task will be for mixing necessary? Then, sure, which requirements do you have for a state-of-the-art mixing technology? And then to show you some realization, heating cooling mixer for PVC compounding application and the state-of-the-art container mixer solution for engineering compounds. I would like to start with the company 𝐏𝐻𝐭. It's a family-owned company in the second generation, and we have more than 120 employees. Next year we will have our 60th anniversary, and since then we have more than 7,000 mixing systems installed in the world. We have 3 test centers, and here to show you a short timeline of the company. 1965 we was founded, and in 1968 we built the first heating cooling mixer. And in 1975 𝐏𝐻𝐭 was the inventor of the container mixer technology. In 1975 the first container mixer worldwide was produced by 𝐏𝐻𝐭. Since then a lot of further developments, optimization, new blade designs. So we did a lot of work to improve our technology and to give our customer higher benefit for their mixing task. One important thing is also 2009, a new container mixer technology, which allows a high dispersion performance without temperature increasing, and the latest development for container mixer is in 2019. And for heating cooling mixer, in 2021, we make a new revision of our heating cooling mixer products, and here we make new designs and a lot of things new, and I want to show you today also some improvements in our heating cooling mixer technology. So, company 𝐏𝐻𝐭 is settled down in the middle of Germany, 2 hours far away from Frankfurt in the north, 1.5 hours in the east side of Düsseldorf. And we have a subsidiary in the US where we have also sales and service. And in next year, 2025, we will have also in China an office where we have service and sales and also a test center there. Around the world, we are working with agencies like SAP here in India, where they are represented us in the local market. A brief overview about our products. First, we can divide it in 2 basic groups. That is the stationary mixer, which will be led by the heating cooling mixer combination with horizontal cooler, vertical cooler, high-speed mixer, traditional mixing design, universal mixer executed as a horizontal or in a vertical direction, and lap mixer also. So when I speak about horizontal, vertical, that means the direction of the shaft. A horizontal mixer has the shaft in a horizontal orientation, and the blades will be installed on this horizontal shaft. Vertical mixer means it's a vertical oriented shaft, and the blades will rotate around the shaft. The second group is a container mixer group. Here we have realized different designs for different application with a standard vortex mixer to build up regular vortex, container mixer multi-tool, which allows a high dispersion performance with reduced temperature increasing, the I4 and also double cone mixer, lab scale mixer, small scale mixer. So you can see we cover a huge range of different mixing applications, and so we can adjust these mixing equipment to your requirements. One important thing of our business is our test center. We have it in the US, we have it in China, we have it in Germany, and here we realize a lot of mixing tests together with our customer, because you can send us your material, you can take part with the mixing trials, and then you can see the performance of our mixing equipment. You can see how it works, how you can handle the material inside, and how you can clean the mixer. So that is a good opportunity for you to see how it works. In our test center, we have installed different machineries, different solutions, and depends on the application. We can adjust the machinery to your requirements. Okay, I think short introduction, we are in a hurry. So I want to introduce you a little bit more on mixing. What does it mean, mixing? Because a mixer, when we as a mixer supplier speaks about mixing, means that we have blades inside, which moves the material inside to get different tasks, to solve different requirements. The first is a distributive mixing. That means we have to take care that all parts of the formulation will be distributed in a homogeneous way inside the mixture, so that every place inside you will have the same concentration. The next step will be dispersive mixing. Sorry to the extrusion manufacturer, because a mixer cannot give a dispersion performance like an extrusion line, but we as a mixer supplier, we speak also about dispersion performance. In general, it means we destroy the particle. We destroy agglomerates, lumps inside, so that we have the smallest particle size inside the mixture. The third task will be the process mixing. That means sometimes you need a process inside to create, for example, a dry material, or you create a new material with lower bulk density. When you, for example, a melting process or a sticking process, then you have to increase the performance of friction and shearing, so you get the temperature increasing inside the mixture, so that your material starts melt or starts sticking together. For example, PVC compound, here we have the temperature process inside the mixer. This is a principal drawing. What does it mean? Homogenization, a distributive mixing, then the dispersion mixing, so that, for example, here the gray parts will be distributed, will be destroyed to the smallest size, and if requested, a process mixing for agglomeration process or for a coating process. Here, for example, with an agent, with a liquid agent to support this coating. Here, I hope it will run. A short, to realize this distributive mixing, we create inside the mixer a vortex. That means material will get a movement by the blades, rotates the blade, the material goes outside and drops by gravity in the middle, down together, so that we have a vortex and the material rotates inside the mixing vessel. Normally it should run a short video, but Technic, can you check if it's possible to show this movie? There is a movie I cannot start. Anyhow, we will see it later in the presentation once again. So don't worry. Let's go, let's continue. It's okay. Okay, then continue. Okay, so we spoke about homogenization by building up this vortex. The next will be dispersion performance. This will be realized by the blades inside. And the dispersion performance depends on the geometry of the blades, of the tool speed of the blades, and sure of the number of the blades. And when we have this process mixing, then we have to increase the tip speed. We have to increase the installed drive power to get the energy inside the mixtures for a heating process. So this will mention with homogenization, distribution, and dispersive mixing. So when we speak about requirements for a mixing solution, so here we have different points which is important for you as a user of such equipment. First of all, homogeneity. That means you will have the best possible premix regarding homogenization dispersion to create the best possible product quality. The second thing is consistency. That means that you have 24 hours, 7 days per week. You have a constant product quality in the premix, so that you will have also constant final product quality. So that's also important for you. The third thing is a cost efficiency. Okay, you can think about which direction or which part is the most important thing. But for me as a mixer supplier, mixing quality is the first, and then the cost efficiency is important. Regarding cost efficiency, sure. First is to see, now I want to have a flexible machinery, that I have different tasks, I have different requirements, different formulation, and I want to realize a mixing solution where I can cover a wide range of different applications. But cost efficiency means also less downtime of the machinery, high machine availability, so that you can produce long time. You don't want to clean a machinery, you don't want to maintain a machinery, you want to work with the machinery. So all these items are really important for you as a customer. And the third thing, flexibility. Sure, as I mentioned, different formulation, that you have different application, and you want to produce your compound adjusted to your requirement. And this must be fulfilled by a good mixing solution. Yeah, now I want to show you, this is a ring of mixing. That means depends on the application, depends on the requirement. We can offer you the right mixing solution to fulfill your requirements. And now I would like to show you a solution for PVC compounding. It is the heating cooling mixer solution. And here we have a heating cooling mixing process where we have to prepare the PVC virgin material together with the additives, with the filler, so that you have a new final product with the best possible performance. It looks like in this way. You have in the upper part the heating mixer, in the lower part the cooling mixer, with some additional equipment for venting, for aspiration, but I will show you more in detail. The heating mixer, here all product parts will be executed in stainless steel, AZ321, but also possible and available other stainless steel types. Then we execute our machinery with high efficiency drive units in IE3 or IE4 types, and we work with German machine supplier, with VEM or WEG as a drive unit supplier, but other drive supplier is also available. Furthermore, we have a special design of our discharge unit because it's an inclined design. That means we have here, during the discharging, a better and faster discharging of the material out of the heating mixer. And this also, that the residual material inside the mixer will be also less. Furthermore, due to the special design of our discharge unit, we can swivel away the flap, and we can clean easily the flap and the discharge housing when you change the formulation. So our focus is good premix, best possible premix, and easy handling for fast cleaning. That's the two core tasks for us as a mixer supplier. Furthermore, here we are working with a maintenance-free metal sealing, and during the closing process, with a blast of air pressure, we clean the sealing area so that we take care that the valve will be tightened. So here, roughly overview about the available machine size. The volume itself is the gross volume of the mixer. That means 200 liter means a gross volume 200 liter. And the useful volume will be 85% of this gross volume. So, and depends on the bulk density, we can calculate the batch size of one batch inside the mixer. So, furthermore, some detail which we also realized in our heating mixer is that we increase the diameter of the bottom shell. Here we have a bigger radius compared to other supplier, and here together with the special design of the bottom blade, we are able to speed up the material during the mixing, during building up the vortex. It speeds up in the upper part, and due to this relative higher tip speed of the material inside the vessel, we can reduce the tip speed of our heating mixer. That means we create a better vortex, we create a high dispersion with reduced tip speed. And this brings big advantages for the customer, because due to this less tip speed, you have less stress to the material. Then less tip speed means you have less wear of the blades and of the mixing vessel. So less wear means longer lifetime of the machinery, longer lifetime of the blades, and less maintenance cost. That's an important argument for a lot of customers which invest in 𝐒𝐲𝐶 mixing technology in the last time. Here mentioned that we are working normally with a tip speed of 10 up to 28 meters per second. And so, as mentioned, we have less stress to the material, and we have a special working angle of the bottom blade, so to build up this vortex in the best possible way. And I hope, here the hardness, okay, to increase also the lifetime of the blades, we can also coat the blades with a special wear coating. It calls tungsten carbide, and here with a thickness of 0.5 millimeters, and we can realize the surface hardness and more than 72 HRC. I hope this movie runs now. You can see what does it mean, a vortex inside with a tip speed of 25, 28 meters per second. It's a movie inside the mixing vessel of the heating mixer, and here you can see how the vortex works. It goes up outside, drops in the middle, and here you can see the shaft, and here you see the good homogenization and distribution of the material inside the vessel. Yeah, we have another challenge in the heating mixer, because everybody knows that material has a residual moisture. Especially the fillers loves to absorb moisture. And then this moisture will bring us problems, not in the heating process, but especially in the compounding process. So here it is necessary to create a high process stability to get out the moisture out of the heating mixer. And here we have the possibility, here we need a dehumidifying unit to get out the moisture. And here we have two possibilities. The standard solution will be an aspiration system together with a jet filter, where this aspiration used one time for venting of the vessel during the charging process, and during the aspiration process, we create an airflow through the mixing vessel, and by this airflow, we take away the moisture out of the vessel. But what happens when the mixer will place in a situation where we have a high humidity in the ambient air? Then we take through the fresh air supply of the heating mixer, we take moisture air inside, and then we cannot dry the material as much as possible. Especially, for example, here we have a lot of monsoon period now, a lot of humidity in the air. So here we cannot work with a standard aspiration system. Here we favorize our vacuum dehumidifying system. We create a small vacuum with 0.2 bars, and by creating this vacuum, we have one big advantage, because then we set down the boiling point of the water inside the vessel from 65, 72 degrees, something like this. means that we have a longer time where the humidity can go out of the mixing vessel, because final temperature inside the heating mixer will be roughly 110, 120 degrees, something between like this. And so we have a longer time where the moisture can go out. So, and that brings us the advantage that we have higher residual or lower residual moisture inside the mixing vessel. We can reach here up to 1% and lower residual moisture inside the mixing vessel. Furthermore, that with the vacuum dehumidifying system, we have a separation of the dehumidifying unit and the venting system. That means that during venting, during the charging process, the air goes by the venting system out, and we have no filter caking on the jet filter. So these are big advantages to keep a high quality product, to keep a high mixing quality inside the heating mixer. So, cooling mixer, yes, it's necessary to cool down the preheated material from the heating mixer. And here we standardize using horizontal cooling mixer due to the better cooling performance. But why we are cooling down? Because we recommend to cool down the material, because then you have a consistent process parameters for the compounding process, because outlet of the cooling mixer will be material temperature roughly between 40 up to 50 degrees, and this will be constant. So that brings you also a stable and high process reliability for the compounding process. And furthermore, when you have cold material, it's better and easier to handle this material. Some more details about our cooling mixer. Sure, also all parts in contact with material are executed in stainless steel. Here standardized AZ321, but also other stainless steel types are also available. We have a double jacket wall inside, and here we realized a special design of the cooling equipment in the double jacket wall, because we separated inside the double jacket wall segments where we have a water inlet and outlet, and through the length of the cooling mixer we have separate segments, and each segment has their own water supply. So when I have a look on the length of the cooling mixer, I have a constant surface temperature inside of the cooling mixer. That brings me a better cooling performance compared to traditional cooling mixer where they have only one inlet and one outlet, because after half of the part of the time, the water will be warmed up and the cooling performance goes down. Finally, you will have only one connection point for the water inlet and water outlet at the cooling mixer. The distribution will be organized by the mixer itself. Here a short movie. Due to the special design of our blades and the cooling mixer, we can use a bigger area inside of the cooling mixer. Here it was mentioned in the right movie. Here you can see that we can use a bigger part of the cooling surface. That allows also a better cooling performance. Furthermore, due to our special design of the cooling blades, it is not necessary to dismantle the shaft. You can, for when you want to exchange the cooling blades, then you can replace it directly only to removing the shaft. That's also high efficiency in regarding the maintenance. Also, the speeds of the cooling mixer can be also adjusted by a frequency converter when it is necessary. Here you can see also the different sizes of cooling mixers. The smallest one, 800 liter. The biggest one, 9,000 liter, with the corresponding drive unit. So the combination of heating cooling mixer here, it's the standardized product range, but also possible to change the cooling mixer to ZT mixer. So that will be calculated when you send us the requirement, when you send us the application. We calculate the corresponding heating mixer and cooling mixer, and we can give you also the water consumption, air pressure supply, everything can be calculated with our design team. Yeah, that's regarding heating cooling mixer. Now I would like to introduce you for engineering compounds, the solution where we realized was a container mixer. The container mixer, it's a different story. Here we have a separate container. We have here different execution of container mixer. We can execute a container mixer like a stationary mixer as a vortex mixer with different drive units to realize also a warming process. Then we have our container mixer multi-tool, where we have the possibility to create a high dispersion premix without temperature increasing. And the latest development, a container mixer, which will be characterized with a flat mixing head, so that you can use different container size in one mixer. In general, as you can see here, the container will be moved inside, will be lifted up, and will be tilted in mixing position. And when he is in the 180-degree mixing position, then the mixing process starts. So that is why we call basic position mixing position, and the big advantage of a container mixer solution is the cleaning position. Because when you want to clean the mixer, or you want to change the formulation, then you tilt the mixing head in front of the worker. And then it's easily for cleaning, because when you compare a stationary mixer, you bend over to clean, you have to dismantle the blade, etc. Here, container mixer, the worker stands in front of, and after 20 minutes, he's ready. A stationary mixer needs 4 or 5 times more time for cleaning. That is the reason why the container mixer is such a success.
Sorry to interrupt, sir. You have only 5 minutes left for your presentation.
Sorry?
You have only 5 minutes left for your presentation.
Yeah, okay.
Okay.
I will see.
Thank you.
So here is also the next advantage of a container mixer solution, because it's not only a mixer, it's also a logistics solution, because you can use the container as a material transportation system. So you charge the material inside, then the container will build the mixing vessel together with the mixing head, and after mixing, the material goes back in the container, and then you can use the container as a storage hopper for the extrusion process. That means that you have not only a mixer, you have also a logistics solution. Sorry. Some basic equipment, double column, tilting drive, mixing head, spindle lift device. Small remark, the spindle lifter lifts up the container and pressure the container with roughly 3 tons per square meter, so that it will be completely closed, and no dust comes out. Container executed in stainless steel, mirror finished quality, executed with wheels, discharge valve, and forklift pockets, so you can move it by forklifter, you can move it manually, different ways are possible. The container mixer multi-tool, it's a special design, because here we have the possibility to create high dispersion performance, but no temperature increasing. When we compare with a vortex mixer, after 4 or 5 minute mixing time, we have a temperature increasing of 20 degrees or more. With a multi-tool, we have no temperature increasing, but we have a high dispersion performance. And this will be realized by a complete different mixing system. It's a patent solution, and here the blue blade, the big blade, rotates very slowly, no vortex inside, and moves the material to the high-speed rotating chopper blade. And the high-speed rotating chopper blade, he makes a high dispersion and destroy the agglomerates inside. And both blades combines homogenization of the premix. This movie, I hope it runs, yeah. So that's the principal view of the mixing of the multi-tool inside. Here you can see now the big blade which conveys the material to the chopper, and the chopper, he destroys the material inside. By adjusting the tip speed of the chopper blade, you can also adjust the dispersion performance of the premix. And for some application, for example, powder coating, here you can adjust also the particle size of the premix you want to reach. So when you see here, there was an evaluation from a customer where he compares different mixing solutions, and he gave us the information about the color strength. Without pre-mixing, we have 62%. Competitor 1 and competitor 2 are traditional vortex mixer, and the multi-tool with a special design reach 20% higher dispersion performance compared to the best vortex mixer here. And this gives you a good feeling that the multi-tool will have the best possible premix for your application. Different machine size depends on the batch size. So, summarize, I think you will have this also in the presentation. Now I want to introduce you in the latest development of container mixer. It is the I4 mixer. This will be characterized with a flat mixing head. So, less area for cleaning. So that will be also reduced cleaning effort. Together with the special design of the blade, it's the 3 arm blades with side wings, where we get a turbulence, and due to this special blade design, we can increase the distance of the blade from the mixing head. That allows that the blade must not be dismantled for cleaning. The worker can only go behind the blades for cleaning. So that is possibilities how we can realize a vortex inside here with a tip speed from 5 up to 50 meters per second. That's really low tip speed. And this movie now will show you how fast this mixer is. This is yellow raw material, and I have a little spoon of red pigments inside. Now the mixing process starts, and now you can see how fast the red pigment will be distributed inside the mixer. So roughly after 20 seconds, you will have, optical-wise, a good premix. But sure, then you need also longer mixing time to get well-dispersed premix also. So when I have a flat mixing head, then I'm available to use different container size from the diameter, because mixing needs a special ratio between the diameter and the height of the mixer. And now, when I have a flat mixing head, then I can use different container size with the same mixing station. That allows that I have a bigger batch range with the same mixing station. And we have a smart container mixer here, which detects which blade is inside and which container will come inside, so that a malfunction is not possible. So that gives you higher flexibility in cleaning, in batch size, and with a high dispersed premix. So also here you can see the different machine size, and this mentioned with I4 Flex, this is the mixer where you can use different container size in one mixer. The batch size will be calculated with a bulk density of 0.5 kg per liter. So when you have a different bulk density, then you can calculate your own batch size here. Yeah, summarize the advantages. I think also here, reduced cleaning time, high availability of the machinery. We can use different container size in one mixer. We have an automatic detection of the container and the blade, so a malfunction will be avoided. And this innovative tool design allows a low tip speed with a mixing time of 3 up to 5 minute mixing. Finally, also a lower energy consumption compared to a vortex mixer or standard high-speed mixer. Yeah, that's more or less the end of my presentation. Sure, we have different auxiliaries. That means we have different tool container, charging station, discharging station. container mover to handle material, the container. So everything is available from 𝐒𝐲𝐶. Yeah, thank you very much for your attention. And yeah, fire free for questions.
So thank you so much, Mr. Bacchus, for your valuable contribution and informative session. Now we have some times for question and answer. So if anyone has any question, please do not hesitate to ask. Is there any questions? Yeah, sir.
Oh, okay. For me, I have my microphone here.
Okay.
Prasad here.
Yes,
I
hello.
have one question. In your heating mixture, what heating media you are using?
We are heating by friction and shear the blades.
See, like in cooling mixture, you are using an external media of cooling water. In your
Yeah, for the cooling mixer, we need cooling water that should be temperized between 13 up to 50 degrees.
Agree. But for heating, you are not using any heating media.
No. Only by friction and shearing.
Okay, but then it can have impact on your product degradation. Because see, if it is by friction and shear,
Yeah.
the temperature will be uncontrolled. Can it not degrade your product?
Yeah, we have a control. You can control the temperature inside. It's possible also to have a control loop, but normally for a lot of processes, it's necessary to reach, for example, PVC compound to reach a special temperature to take the PVC corn that gets sticky, that the additives and the filler will be combined with the PVC corn.
Okay.
So here it's only necessary to reach this point that will be controlled by the control system. So and when we reach this point, then you can discharge the material to the cooling mixer.
What I understand that your majority of the equipments are used for PVC. Do you give for other products something like as a polymerizing reactor like?
For pulverizing, you cannot use it. Because, yeah, a mixer is a mixer because we can destroy agglomerates, we can destroy material lumps, but it's not a mill. I will mention when you have a finger with your fingernails and you can destroy it, then it will be also destroyed by heating or by a mixer. But a mixer is not a mill. You're welcome.
Is anyone having any questions? Okay.
Yeah, myself, Sarak. We have 7 mixer at our plant. Out of 7, 3 are high-speed HSM 1200 and 4 are CM 600.
Yeah.
So in many of cases, we face dispersion problem where pigment quantity is very less. So we have to mix our trolley 2 times.
Yeah, okay.
Otherwise, we are getting a color difference and color variation. In
What kind of mixer you have? Is it a vortex mixer?
We have a container mixer.
Yeah.
CM 600.
From 𝐒𝐲𝐶?
Yeah, from 𝐒𝐲𝐶.
Yeah.
We have total 7 mixer from 𝐒𝐲𝐶. Out of 7, 4 are CM 600 and 3 are HSM 1200.
Yeah.
And we are producing ABS.
And how long is the mixing time?
Mixing time is around 3.5 minutes.
Yeah, okay.
For container mixer.
The recommended mixing time will be roughly between 3 up to 5 minutes.
Okay.
When you have a less amount of pigment, we have 2 recommendations. One could be to tilt it back in the basic position and tilt it up in mixing position.
Okay.
And then mix 1.5 or 2 minutes once again. Then I'm pretty sure you will have a better premix.
So you mean to say we have to increase our mixing time from 3.5 to maybe up to 5?
Yeah, you should increase also. So I recommend 2.5 minutes. The first step, tilting back, tilting up 2.5, and then it will.
So right now we are doing the same. We are mixing it twice.
Yeah.
So one mixing, then another could probably come down, and another second cycle.
Yeah.
So to save our lifting time up and down,
Yeah, but here it's no lifting necessary. We only go in basic position and then tilt it up in mixing position.
Okay.
Please let me know which kind of mixer. Perhaps we can retrofit this mixer with this. It's a software application on the control system.
Okay. So we'll try with this recommendation and we'll let you know.
Okay, that will be fine.
Yeah, thank you.
Thank you.
Is there anyone left for the question answer? Thank you so much, sir. Up next, we'll be exploring managing the compounding process of sensitive formulations using continuous kneaders. We are excited to hear from Dr. 𝐏𝐻𝐿, Director of Sales Compounding Lines at 𝐿, a Troyster company with extensive more than 20 years of experience in the compounding as a researcher and in a technical sales. He specializes in stimulating compounding processes and working with the various polymer and equipment. He looks after the sales of continuous kneaders, plant, marketing and business development, both in India and overseas. His insights on this important topic will be invaluable to our discussion today. Please join me in welcoming Dr. 𝐏𝐻𝐿.
Thank you. So yes, good evening. Thank you that you're joining my presentation. Thank you to all the SAP team for this wonderful organization of this event and for letting me talk on this beautiful event. So today my talk will be about managing some kind of demanding, what are called sensitive formulations. I'm talking to this because our kind of technology is actually dedicated for sensitive, for demanding formulations. But before I start, let me talk a little bit about our company. 𝐿 is part of the Troyster Group. Troyster is a German machine manufacturer, medium-sized, family-owned. It was founded 1892 and has basically 3 columns of business. For me, obviously, most important is the compounding machinery division. The second column is the cable machinery division, and the third one is rubber machinery division. So we're providing extrusion lines, plants for rubber, cable, and compounding. In total, we are roughly 650 to 700 employees currently worldwide. So Troyster is located, headquartered in Hanover, Germany. We have sites in Mexico, US, India, China, and Switzerland. The small red, it's not working. So in Switzerland, and our representative here is SAP. Our setup as 𝐿 is our engineering, our technical center, our spare parts, our sales is located in Switzerland. The machines are manufactured and assembled in Germany. So our scope, what do? We provide continuous kneaders. I will come shortly what I mean with this. Just the kneader, just the extrusion plant or extrusion line up to total turnkey plants. So before this question comes, we will work together with partners for the turnkey plants. So we will provide again the kneader, but we will do work together in engineering to setting up complete plants, including everything. So, sensitive compounds. What do I mean with this? I mean with this basically compounds that are sensitive to shear, sensitive to temperature, or a little bit different, but very highly filled. Speaking of our main application where our kneaders are sold, this means different kind of cable compounds, halogen-free flame retardant cable compounds, semiconductive cable compounds, cross-linkable cable compounds, all kinds of PVC compounds for calendar feeding, for, let's say, medical application, later on also for flooring application, PVC compounds, medical, wiring cable, also others. All kinds of elastomers, master batches, black, white, additive master batches, some thermosets, and specialties,
all range of help coming from highly filled metal compounds, highly filled ceramic compounds, fluoride, so PVDF compounds, or even chemical reactive compounds. So, oops. That mic is on. So, what does it mean for the requirements that comes with these compounds? For shear sensitive, for sure that means you need to avoid degradation. This involves a controlled residence time of the compound. That means controlled energy input. If either of those is uncontrolled, then you run into issues. For temperature, additionally, you need usually a quick access to the processing unit, as sometimes it is required to do quick maintenance, to quick changes, so it isn't required. And for temperature, it's not only degradation, but if you got cross compound, you might also run sometimes into pre-scorching. You want to avoid this. So there is another challenge. And for highly filled, actually it runs down to two requirements. You want to add as much filler as possible usually, and you do not want to accept any wear if possible. So there will be wear, but you want to reduce it as much as possible. Besides this, there are the standard requirements. Every production line in the world has like a high productivity, high energy efficiency, as flexible as possible, and to produce the best quality possible. Maintenance is in the middle because that prevents us a lot of the productivity and flexibility. So, our solution for all these special challenges and demands are continuous kneaders. So continuous kneaders, in our view, are single screw compounding units, where the first point is the screw is not only rotating, but also oscillating, like moving backward forwards, as you can see in this animation. If you look closely, you will also notice the pins in the barrel that also enhance the mixing. So what does this do? So we have a clamshell barrel, so to open it you have to move a couple of bolts and then you get access to the processing section. Every part in contact with the material is exchangeable, is modular. So the pins in the barrel, the liners, there were always liners, and also the screw, that comes a little bit later. Yeah, the screw is also modular. So easy to adapt to a certain kind of application, to new challenges, everything can be adapted accordingly. So coming back to the pins and the screw, what does this make for this special type of application? If you follow a pin, the path of the pin, in this case this one, it will paint a line of banded ring on the screw root of the fur face. So if you do it with all, you get a picture like this. It's a little bit confusing, but it gets more clear as it stops in a second. So you see pin and flights wipe out each other. So you got a more or less self-cleaning environment, which is good to avoid degradation, pre-scorching, and so on. Second thing, well, first thing, it's good that nothing sticks somewhere and you get everything out, but still you need to do some mixing. So the mixing principle of a continuous kneaders, it's a staff fed unit, so with gravimetric feeders. So it's a staff fed unit. So the mixing principle is like making a dough. You stretch the material as it is pushed by the dynamic flight through this gap with the kneading teeth. So it's stretched, and then it's folded back together. In the next section, it's stretched, folded back together. So it's stretching and folding, like making a dough. And if you do it in the kitchen, you will notice it's different from a turbo mixer where you heat up by friction. This will not heat that much up. So it's a very gentle type of mixing. And as it's a stretching type, the scientists call it kind of elongational mixing. And elongational mixing is known to be very gentle on one hand and very efficient on the other hand. So, it's the basic principle of our kneaders. So coming back to the challenges, how do we control, let's say, the energy intake? You've seen the complete modular setup, which is a nice thing. So what we can do, we can play with the geometry of all the different parts of the elements. Like you have, if you take the screw as given, then you can play with the geometry of the pins. Make them an angle, a conical one, make it a straight. The other two over there are like prisms, like look like diamonds in the cross section. So you can adapt the shear just by the geometry of the pins, which you can basically choose very wisely. And this is only one example. Obviously, you can also play with the screw geometry to enhance or adapt the shear rate. Second thing to play with is in this kneader are static restrictors, let's call them. So a ring you put in the processing section to adapt the filling degree locally. What you can do is have them made into the liner or put them on top of the liner. And what you can do is by changing the inner diameter of this ring, you can have more shear or less shear. And so you can play also with this one. And this is really what happens. A lot of our customers use these, what we call flexible restriction ring. They never change the screw configuration. They run a whole bunch of different materials, from engineering compounds to polyolefin compounds, with the same screw configuration, just changing this restriction ring. So and this, like for a production line running 2.5, 3 tons an hour, this takes 2 hours. To open the kneader, change the restriction ring, put everything together, heat it up, and you're up and running. So, controlled temperature history, like for temperature sensitive compounds, obviously, this is kind of an important thing to control temperature, right? So what we can do is, like if you know extrusion, what's the best way to measure your melt temperature? Usually you have like a thermocouple at the screw tip that reaches into your melt, right? So this gives you by far the best reading you can have. So we got pins. So we can use these pins, put thermocouples inside, and then we can measure at any location along the extruder or the kneader to monitor the temperatures, which is it's actually a beauty. So you have a very good, as accurate as it can be, temperature monitoring for your compounds. And especially if you got reactive compounds, if you need to do a grafting reaction, this is kind of useful information. Actually, what you can do, it's not in the presentation, like the thermocouple here, this drilling, it does not go through, but you can also drill it through and then inject a liquid feeder, maybe a Brabender liquid feeder to it, and then inject liquids. Also, this is kind of a cool thing, because coming back to the dough is, well, if you have the dough, put some oil on top, and then try to knead, it's not that easy. Now, as I said, mid-stretching and folding, what we do is stretch, put the olive oil on top, fold it, like you do it in the kitchen. And then you get as easy as it can be mixing, like 2 different viscosity liquids is always difficult to mix, but this for sure enhances. So some ideas about the energy intakes we have in our compounds. So obviously there is different from the different kinds of compounds. Like usually for PVC, whether it's calendar feeding, if it's compounding, as just a few kilowatt hours per kilogram are good. If you want to do cross-linkable XLP saline, you need to add some energy. You need really energy. You're around 0.17 to 0.2, depending on formulation. That's the demand of the compound. But as with the measures I mentioned earlier, it's possible to be on the lower end what's required by the formulation. So you control the energy and you can just add what is required and not too much more. So, and highest filling degrees, it's different to bring a slide on highest filling degrees. So I just brought one for some flooring compounds. So who's not familiar with this? This is a backing compound of a kind of PVC flooring. It's called SPC. It's a rigid type of flooring based on a rigid PVC. So when I started with X compound, I was saying filling of rigid PVC in standard is round about 50–60% by weight with calcium carbonate. That becomes difficult. And as you can see here, we end at 70–80% by weight calcium carbonate compounds. So we can really achieve very high filling degrees of fillers also for different kind of applications. So what does a line in total look like? So we have a kneader and an extruder attached. You can swivel away the hoppers. The extruder, you move away the barrel. It comes later. Open the clamshell barrel, and then you put in liners and the pins. It's a little bit longer, so it takes a little bit. Then this flexible restriction ring comes in this case, the first one to enhance melting. More and more pins come in. Degassing dome. Second one with a vacuum dome. And then we are finished with the barrel. Now the screw come in, assemble the screw. And we're done with this one. You can also see the injection port for liquid feeders. Now you put in, and you can see also for the discharge extruder, which we need for building up pressure going through underwater pelletizers, changer, whatever. We like to separate these two units to control the temperatures. And you could also see for the extruder, you could pull away the barrel, leave everything in place, which is for maintenance point of view, the most economic way. It's like the quickest way to do it. So we think that our lines does offer a unique combination of features. Like for the self-cleaning, obviously, is good when it comes to avoid pre-scorching, also to material degradation, and also in kind of chemical compounding, chemical reactions, reactive compounding. You want to control the residence time. Elongational mixing is very efficient and gentle at the same time. The large gaps I showed you also give some beauty. It gives low wear for highly filled compounds. And I didn't mention this, we are standardly running on very, very high, very low screw speeds. So we are running basically at like 100, 200, maybe 250 RPM compounding speed. So you're welcome to join us in our compounding lab in Switzerland. So we have a real scale compounding lab that can scale to our biggest production lines. The biggest production line can produce like 10 tons an hour PVC. This one is made to give proof validator for the scale up. It's equipped with all different kinds of auxiliary equipment to meet as much equipment as possible, or requirements as possible. So I'm finished with my presentation. I would be glad to answer your questions if you have any. Thank you so much.
Hello. Thank you so much, Dr. 𝐒𝐻𝐿, for your presentation. Again, it's time for question and answer round. Anyone has any questions?
Okay, good afternoon, sir. Perhaps it's good evening. Anyway, don't mind. Sir, I have a question. The question is exactly, have you heard of this mineral paper? This PVC or that PET materials and PVC basically for sustainability, you know, they are actually facing that recycling actually, in which these materials around, they are filled with calcium carbonate or magnesium components with around 85 to 90% actually. So basically these materials are very hard to actually, you know, process. So does these actually these you know additives hampers the screw actually, the durability of the screw actually for this dosing, for this process of blending?
So to be honest, we never did this artificial paper.
Okay.
We never did it, but for carbon black master batches, we are well above 85% of calcium carbonate.
Yeah.
So I'm actually sure I know of this application, but we have no proof so far.
Okay. No, because these actually in Austria actually, when I was in my college days actually, again, I was working on this project actually.
Okay.
So the future planning of this packaging industry, single-use plastic, is just like they want to actually introduce this mineral paper packaging actually. For this actually they want to introduce around 85%, around 85 to 90% of these fillers with this PVC or your Duotech PVC or PET material. Basically these are single-use plastics. No.
Yeah.
So what is this impact of these actually components, magnesium also or calcium with these actually screws actually? That was my question. Anyway,
but I can answer one point, is like when it comes to these kind of filling degrees.
Yes, sir.
It's not really just the point of who's the best compounder.
Okay.
It comes to who's got the best solution, like total solution.
Okay.
So with material handling, we need a good solution for material handling. We need a good solution for feeding, because you're running really at the edge of what is possible.
Yes, sir.
So so if the polymer feeder varies too much, then you run into problems.
Yes, sir.
And this is kind of not a solution just from a compounding provider, but it's a joint solution.
Yeah,
of,
from
of a
utility
team.
and all everything, It is a teamwork.
Yeah.
At the end of the day. Okay. Thank you, sir.
You're welcome.
That's all my question.
Good evening, sir. I am Yagnaraman M from Apollo Tires. Actually, I have one. I want to understand that generally in our batch process, we fix our concentration of PHR, parts per 100 rubber. How will control in this? Because suppose we need a 50 kg output, we have fix everything. Means 20 kg rubber, then 10 kg other chemicals and oils. So how will take care in this case? In continuous mixer.
So in case of a rubber compound, like
yes,
rubber is the most difficult part. So all other ingredients, for sure, you can go with gravimetric feeders like we've seen before, like talc, like carbon black, like calcium carbonate, whatever. You can just use standard state-of-the-art gravimetric feeders to add these. For the rubber, we need to discuss in detail, let's say, put it like that. There are solutions, but for sure there are not too many easy solutions. Huh?
Thank you.
Yeah.
Sorry.
Dr. 𝐒𝐻𝐿, pretty impressive presentation.
Thank you so much.
Do we have a choice for different metallurgies, MOCs?
Yes. So our standard MOC would be stainless steel. But let's say we as I mentioned, we are in different applications. So we use also alloy materials, but we have, like if it's PVDF, for instance, then there will be for sure some alloy material, but that's easy because they're usually not highly filled. Because you can live with high corrosion resistance, but almost no wear resistance at this point. If you need a little bit of both, then we have to discuss. But we work, obviously, alloy materials like Astelloy on one hand, like corrosion resistance, And we have also tungsten carbide coated elements on the other side, high corrosion resistance. But let's say, honestly, like most of the applications run with stainless steel.
Okay, and I just browsed your catalog.
Pardon?
I just browsed your catalog.
Yes.
Most of the equipments listed on catalog.
Now, it's the other
pretty
materials of
industrial
construction
scale.
are not mentioned because, well, as I mentioned, usually if it's not a very dedicated application, then either stainless steel or plasma nitrated stainless steels are good solutions. Because, as I mentioned, like due to this modular setup, you have dedicated parts that wear out quick, so you can replace them. So it's usually much more cost efficient to work this way compared to getting, let's say, alloy material, which is kind of factor 8 in the raw material price to the stainless steel. Huh?
Just one last question. Do you have any equipment for laboratory scale trials? Laboratory scale trials, small scale trials?
Sorry, I didn't.
You're starting at 45 millimeter.
Yes.
So do you have any for small scale trials? Most of the equipments listed on your catalog are pretty industrial scale.
That's basically what's listed on the
R&D
catalog.
scale, I'm asking.
45 is, well, the reason for the 45 is low is I didn't mention this in the presentation. All areas, let's say, all screws and all barrels are liquid tempered. So that's very, very important for us. So, and then in a small scale, we cannot go lower because then we lose the liquid temper because no space for that. So we decided to stop at 45.
We can connect later.
Yeah, sure.
Thank you.
Anyone left for the questions? Okay, ma'am. Thank you. Thank you, everyone.
Okay.
Hello. We are now moving to an interviewing session about the compounding technology of JSW twin screw extruder. It's my pleasure to introduce Takehiro Kato-san, Deputy General Manager at JSW. Kato-san brings an impressive 25 years of experience at JSW, having held numerous key positions, including the current role as a Deputy General Manager of the new extruder business, and Hiroki Shintani-san, Mechanical Process Electrical Engineer from the Compounding Extruder Engineering Department at the JSW Hiroshima plant. Shintani-san has been with JSW for 10 years, contributing his expertise to the Compounding Extruder Engineering Department. Please join me in welcoming Takehiro Kato-san and Hiroki Shintani-san.
How can I change the... this one, okay. Okay. Hello everyone, this is Kato speaking from JSW Tokyo head office. Today, thank you very much for your coming to this event. I'm one founder of this event, so I'm very happy. And also, I very great thanks to the SCP people. Thank you very much. So from now, I and Mr. Shintani here, is the engineers, make a presentation about compounding technology of JSW twin screw extruders. The reason why we choose these titles because JSW has a big confidence about technology of our extruder business. That's why we choose these titles. Please listen to us. Oops. Then this is our group philosophy. So all JSR staff are working every day under the purpose material revolution. Material revolution making the world sustainable and prosperous. Then to reach this sustainability target, we solve the materiality issues through the development and implementation of the industrial machinery and new material. Then this is the list of materiality issues related to our equipment. For example, this realization of the plastic resource and recycle society. To solve these issues, we can provide our twin screw extruder for biodegradable plastics and for the biocomposite and chemical and mechanical recycle, and also global standard specification twin screw extruders. Then this is our manufacturing product in 𝐗𝐶. 𝐗𝐶 has two divisions for the main business: industrial machinery business and material and engineering business. Now, currently, our sales are 70% of the sales for the industrial machinery products. Then these machineries, we are targeting the market plastic, mobilities, and high-performance battery and electric device and defense equipment to supply the extruder series and injection molding machine and film and sheet equipment and defense equipment. Then this is the flow sheet of the plastic machinery. 𝐗𝐶 is the only manufacturers can supply the upstream equipment to the downstream equipment. For example, the upstream equipment, polymerization, isolation, and pelletizing. We can supply the big extruder for polyolefin, and also dewatering and deblatizing extruders. Then the compounding sections, we can supply the TEX, our twin screw extruders. Then the molding sections, we can supply the film sheet machine, blow molding machine, and injection molding machine. Then after the consumptions, we have technology to the mechanical recycle and chemical recycle to return to the compounding pellet and the monomers. Then we can supply our twin screw extruders. Then this is the history of our extruders. First, in 1950s, 𝐗𝐶 established single screw extruders. After that, in 1979, we manufactured the first twin screw extruder, TX55. After that, we developed our technologies, two divisions. One direction is the largest development. Then in 2007, we finally manufactured deblatized large-scale twin screw extruders. We call TEX400. The actual screw diameter is 443 millimeters. So this is the biggest extruders in the world. Then on the other hand, stronger development. In 2012, we finally manufactured customized twin screw extruders, TX Alpha 3 series, this super high torque type. So we have 70 years for the history of the extruder business. Then for these years, we supplied 5,500 units to all over the world. Then this is our extruder model of extra torque density. Then first generation in 1979, we call TXS series. The torque density just 5.3 Newton meter cubic centimeters. But currently, the latest model, 8th model, 8th generation, TX Alpha 3 series, the torque density is 18.2 Newton meters per cubic centimeters. This is the highest torque density in the world. Then this is the future of the advantage of TX Alpha 3 series. Ultra high torque, I explained. So if we compare our previous model, TX Alpha 2 series, the 36% higher operation torque. And that reason, also the 40% higher throughput compared with our previous model. Then, due to the higher stroke, so lower polymer temperature and high mixing abilities. Then number 4, improved durability. So when we developed this Alpha 3 series, we optimized and redesigned the main components, the gearbox, screw shaft, and barrel. So we can supply the improved abilities and high reliability machines. Then this is the trend of extruder market. So currently, the super high torque machine we call customized machine is the market growth is low. But on the other hand, the high torque machines we call global standard machine is increasing. So please see the right the table. This table shows the sales amount and sales number of the unit for each categories machines. The basic machine, global standard machine, and customized machine. Please see the sales number of the customized machine. In 2018, total 600 units, but to the 2020s at the COVID-19, they decreased 400. But now the increasing again, but the market growth is only 1.9%. It's very low. But on the other hand, please see the global standard machines. This is the same decreasing and increasing now, but please see the market growth in the 5.7%. It's much higher than other categories. So the reason why the high torque machine is increasing, there are no need super high torque machine for general compounding applications like olefin, master batch, engineering plastic, and mechanical recycle. So we suppose the currently new trend of extruder business market is a global standard machine. Then this is a material application of the extruders. So only customized machine can be applicable the dewatering, devolatilizing, special compounding, reaction, and chemical recycle, and fluoropolymers, and the part of TP, TPV. On the other hand, global standard machine can supply these material applications like olefin compound coloring, master batch, engineering pressing, general compounding, glass fibers, mechanical recycle, filler compound, polymer alloy, super plastic, high filler GF compounding, and biodegradable plastic. So you can see the global standard machine can cover a lot of applications. Then this is the future of global standard machines. It's not super, just high torque. Then torque density is 11 to 13 Newton meters cubic centimeters, and also high cost performance and short delivery, and so good quality. So this trend is the market is required for the global standard machines. Then this is a global compounding plastic market. So please see the right side tables. If we see the market size of the plastics, China's, Europe, North America's a big market. But please see here the growth rate is not so higher. Then please see here the India's. The market size the bigger, and also growth rate is very high rate is 7.2%. This is number one rate if you compare the other regions. So the market is growing up again after COVID-19, and especially India market has the biggest growth rate in the world. Then this is India plastic industry overviews. So you can see the Indian compounding plastic production is growing up, and also the number of plastic companies is increasing. Then so Indian government also support and help such companies as the policies. So demand for the plastic market in India is expected to grow significantly in the future, driven by government policies to promote industry and the improvement of the standards of living of the people. Then this is the history of JSON again. So after the developed customized exercise, we are developing high cost performance. Then in 2015, 𝐗𝐶 acquired the 𝐿𝐶. 𝐿𝐶 is the #1 twin screw extruder manufacturer in Korea. So they have a global machine 𝐒𝐞𝐚HA series. Then and also 2022, 𝐗𝐶 also make the global standard machine TEX Alpha R series. So this TX Alpha R series is made in Korea in the 𝐿𝐶, because 𝐿𝐶 can supply the demand of global standard machine, the high cost performance and short deliveries. Then this is the picture of the TX Alpha R series. This model is TX54 Alpha. Screw diameter is 54 millimeters. I think it looks so nice. Then this is also a history of 𝐗𝐶 model, torque densities again. So after the 8th generation, that is Alpha R series, 9th generation. Then torque density is 13.2. This is also same as our previous model, 7th generation TX Alpha 2 series. Then this is application of TX Alpha R series. We have 5 models of this. Then from TX44 Alpha R series, 54, 65, 77, and 90 Alpha R series. Then also screw speeds, max speed 1000 RPM. So we can propose the most suitable model to you according to the application and the customer's request. Then this is a final page for me. This is the future of TX Alpha R series. First, design of screw and barrel section is as same as the TX series made in Japan, 𝐗𝐶 Hiroshima. Therefore, so TX Alpha R can get same property and quality with TX series made in Hiroshima. So 𝐗𝐶 supplies the drawing to the 𝐿𝐶, the screw and barrel. So 𝐿𝐶 can manufacture the same extruder of our TEX. Then second, screw design is decided by 𝐗𝐶 according to 𝐗𝐶's huge and long experience and know-how. And the number third, TX Alpha R is inspected based on 𝐗𝐶 standards. Therefore, we can supply the best qualities. So as I said first, 𝐗𝐶 has a big confidence about technologies. So from now, Mr. Shintani explain about our technologies extruders. Thank you, Mr. Shintani.
Okay, so I will explain 4 important topics about twin screw extruders. First, I will explain the basic specifications of TEX. This video shows how the twin screw extruder works. Raw materials enter from the left and are mixed by the screws as they move. The screws have 2 parts, the conveying section and the kneading section. The conveying section moves the materials, and the kneading section mixes them. This video shows silicone oil flowing inside the clear extruder. You can see complex flows inside. This is what the inside of the kneading section looks like. The screws in the twin screw extruder screen themselves. The screws and the barrel fit together perfectly. So the polymer keeps moving. This prevents the polymer from staying in one place and causing quality problems. This self-cleaning feature is very important for the twin screw extruders. Next, I will explain the screw configuration and proprietary technology. The most important part of a twin screw extruder is the screw configuration. Here are some examples of screw elements with different shapes and purposes. Kneading elements mix and melt the polymer. Conveying elements move the materials forward. Special purpose elements used for special tasks. These screw elements are combined in different combinations to form a screw configuration. Here are some examples of screw configurations for different processes. As you can see, each screw configuration is unique. Next, I will explain how interesting mixing and kneading inside of extruder is. Here, let's think about making chapati with peanuts. To make chapati, first, you make the dough, you mix water and flour to make the dough, and then you add the peanuts. Now, how would you knead these peanuts into the dough? Let's think about making a peanuts chapati. This is regular chapati dough. Now, I want to add the peanuts into the dough, making the peanuts small, smooth, and well mixed. How would you do this? At first, you take the dough and pour peanuts on it. Would you use a knife to cut the peanuts into small pieces? Or would you use a hammer to smash them? Which is better? A knife works okay, no problem. But the hammer is faster and makes smaller peanut pieces. I think you would understand. For this purpose, you should use a hammer. The point is, using the right tool makes things easier. Crushing and mixing may not be difficult, but doing it efficiently, you need technique. Okay, going back to extruder. The combination of screw elements is very complex. Even with standard screw elements, there are 171 types and 144 are for kneading. The kneading zone in the extruder screw is made of combination of these elements. Let's say one kneading section has 6 elements. There are over 80 billion possible combinations, which is almost infinite. To get the best performance from extruder, we need to find the best combination, which requires experience and skill. Here, JSW has been a leader in the compounding industry for 50 years, and we are screw configuration expert. We can provide excellent screw configuration. I will explain some of the JSW's special technology. At first, the TKD screw made by JSW is a special kneading screw with a twisted tip. It improves conveying and reduces fill rate. If you use twin screw extruders, how would you change the screw configuration to decrease the polymer temperature or increase conveying? Usually, you would use a right-handed kneading elements, which is correct. But if you want to reduce the temperature even more or increase conveying even more, there are usually no more options. With the TKD screw, you can get even higher conveying and lower fill rates. Reducing temperature more than regular right-handed kneading screws. JSW's extruders use these special screws to improve performance. Next, I will explain JSW's special technology called SFD. SFD is a side feeder with a degaussing filter. As raw materials go into the extruder through the side feeder, they pass through a degaussing zone where the filter removes the gases. This process compresses the low bulk density materials before they go into the extruder. This improves the efficiency of material conveying inside the extruder and increases processing capacity. This technology works for high filler compounds like talc and calcium carbonate. This software called TextFan was developed by JSW. To use it, you just input data like polymer properties, screw configuration, and operation conditions. The calculation takes only a few seconds, and you get results like polymer temperature, residence time, polymer pressure, energy input, and solid fraction. Computer simulation won't give you a direct answer, but it shows you what's happening inside the extruder. You can use this as a guidance. Many people around the world use this technology to better understand the extrusion process. Next, I will explain about the scale-up experience. Over many years, we have made extruders from Tex 25 to Tex 400. For lab use, you would use a small model like the 25mm diameter extruder with a throughput of about 50 kg per hour. For small-scale production, you would use a mid-sized extruder like the 44mm one with a throughput of up to 800 kg per hour. For large-scale production, extruders can be as big as 400mm with a throughput of up to 60 metric tons per hour. Like this, the throughput of twin-screw extruders changes with machine size, but the pellet quality must stay the same. This is not easy. The fact that Tex 400 exists, it proves JSW's high technology and our advanced scale-up technology, as well as the trust and relationship we have built with our customers. Next, I will explain the metallurgy specialization. As the name, Japan Steelworks shows, JSW is the steel company. We have a steel mill and large hydraulic forging presses. We make everything from turbine shafts for power plants to Japanese swords. JSW is the top manufacturer of twin-screw extruders, with a lot of technology in making steel and alloys. The extrusion process has various needs. Some require wear resistance or corrosion resistance for screws and barrels. Whether high wear resistant or highly corrosion resistant materials are used, you need to balance the properties and cost. This is very important. In addition, mechanical stability is very important. No vibration, no noise, and it is the basic of process design. To do this, it's very important to design the screws and process properly. So here, we need to consider both points, mechanical stability and balance between wear resistance and corrosion resistance when designing the process. JSW is highly specialized in these areas because we are steel manufacturer, we know steels, and also we are process designing expert. Finally, I will introduce the various processes carried out with JSW's twin-screw extruder, TEX. I will explain the general extrusion process. First, when mixing fibers with polyolefins or engineering plastics, you need to design the screw configuration to avoid breaking the fibers, so these distribution screw elements are used. Next, for polymer alloys, if the polymers are incompatible, kneading can be done with a simple setup, but it all depends on combination of polymers. For polypropylene compounds for automobiles, polypropylene elastomers and talc are fed into the extruder. You need to achieve a high material conveying and maximum shear stress. JSW extruders are used by many Japanese automobile manufacturers for this process. For high filler compounds, side feeding is often used to prevent agglomeration. After side feeding, an optimal screw configuration is chosen to apply strong kneading and high shear stress. Next, I will explain about mechanical recycling using a twin screw extruder. This is an example setup for mechanical recycling for crushed polypropylene film and crushed polystyrene. These materials have very low bulk density, so they can be easily fed into the extruder using standard feeding methods. Therefore, a compactor, which is a compression device, is used to feed them into the extruder. Next, I will explain chemical recycling technology using a twin screw extruder. On chemical recycling process, it melts plastic with high energy and breaks it down to the molecular level. In this video, you can see gas of decomposed plastic is coming out from the extruder into outlet safety cover. Polymers that can be processed by this method include PMMA, polystyrene, PET, polycarbonate, nylon, and polyurethane, and so on. The processing capacity ranges from 5 kg to 50 kg, depending on kind of polymer. Let me explain another recycling method, which is the vulcanization technology. Cross-linked rubber, like that in regular tires and weather strips, does not melt because of its cross-linked structure. Traditionally, recycling these materials, autoclaves is used to remove the cross-link, which was slow and used a lot of energy. However, with twin screw extruders, rubber materials can be continuously fed into the extruder, where high shear and heat break the cross-links, turning the cross-linked rubber back into recyclable non-cross-linked rubber. This method is very efficient and a better way compared to autoclaves methods. We have a large technical center in Hiroshima, Japan, with 14 trial extruders. We also have technical center in Germany. We can conduct compounding, devolatilizing, and dewatering trials at these two locations. By using the test center at these locations, we work with our customers on various projects. With our long history of knowledge and expertise, utilizing these test facilities, we promise to choose the best equipment, include the optimum screw configuration of twin screw extruders, and provide the best possible equipment. This concludes our introduction to the twin screw extruder TEX. Thank you for your attention.
Thank you both of you for your presentation. Anyone has any questions? Yeah.
Hello, good evening. Yeah, I have seen one point of fill factor. That is how you calculate fill factor here?
This is depend on the applications. What kind of application you consider?
Now, I have just seen that some input you give, like polymer and detail, then the output will be what should be the fill factor, what will be the polymer temperature. So I want to understand what is that fill factor.
Fill factor means polymer filling ratio in the barrel.
Yeah, that I understood, but how you are calculating that?
Then geometry of screw and barrel and polymer density. Okay, this can be calculated. Yes.
Okay, actually in rubber industry we calculate with the net volume, which is without the screw, and what is the space available in the Banbury. Like that we are calculating. So that's why I asked this question. Okay, thank you.
Anyone left for questions? Okay, thank you so much. Thank you so much. This is a gentle reminder for anyone who hasn't yet completed the feedback form. We kindly request you to fill it up at your earliest convenience. Your insights are important to us and we truly value your feedback. Thank you for taking the time to share your thoughts. Thank you so much, everyone.
For our final session, we'll be exploring innovation leadership in underwater palletizing systems. We are delighted to welcome Mr. Ram Dayama, Chief Executive Officer of Econ Machinery Private Limited. With 24 years of experience in the plastic processing machinery industry, Mr. Dayama has driven strategic growth and innovation, and his leadership spans global technology companies. He has consistently fostered lasting customer relationship and marketing leadership. Please join me in welcoming Mr. Ram Dayama.
Good evening all, industry leaders, business partners, and valued customers. Myself, Ram Dayama. Before starting to my presentation, I would like to give thanks to SAP teams for organizing all industry leaders, technology leaders in one roof, and those who are related to the innovative products with their field and applications. So, as you have seen that our tagline is start with palletizing in our DNA. That means we know the applications by heart and we design a palletizer based on our applications. Econ GmbH is owner-managed organizations, and we are highly flexible in terms of providing solutions to customers and registers more than 40 patents as of now. Econ, like technology leader since 1999, and our founder, Mr. Gerhard Ehrenberger, his vision to establish this company in 1999. We have headquarters in Austria that is very close to Linz, and dedicated R&D setup contains customers' idea into reality. We have set up with palletizing twin screw extruders, so where we invite our customers to bring your materials, conduct your trials, and convert into your idea into reality. So how easy it's operate and proof palletizing. So we also provide a tailor-made solutions based on your applications. So for that, we always recommend our customers to please, if the application is regular, so we don't need any trials and reference. We have huge reference with the applications. If the application is new for us, then we recommend trial before buy. So as we had patent technology in thermal insulation die head designs, which we cover in next slides. So as I informed that in 1999 early is 𝐒𝐭n established, then we introduced thermal insulation technology in 2002, then automotive hydraulic locking we provide in 2008, that is the USP of 𝐒𝐭n. Then we introduced 2012 laboratory palletizer systems, that is tabletop palletizing systems. We have servo control knife adjustment is a very important factors to have a uniform size of pallets. If knife is variations, then you having uneven size of pallets. So we control knife force through servo drives. We introduced EVA hybrid systems in 2016. That is again a combination of air palletizing as well as underwater palletizing. So you are getting one palletizing system with two applications. Then in 2019, during the KSO, we announced our new innovative technology, 𝐒𝐭NIA. 𝐒𝐭NIA is a fully automatic palletizing systems, and it's proud to us that we are the first who developed 𝐒𝐭NIA is a fully automatic systems in the world. And some of our awards are mentioned in the below, like regional award for innovative Upper Austria, innovative awards for national award for innovation Austria, Austria Export Awards bronze categories in 2018, business awards for silver categories, then Julius Awards, and recently we awarded biggest palletizing systems in India. That is our achievements during over a period of times. Now we come up to 𝐒𝐭n India. This facility is close to Pore, and it is a 100% subsidiary of 𝐒𝐭n GmbH. That means the founders formation of 𝐒𝐭n India is 2013, located at Baroda near to Pore. We have very skilled trained teams, ISO 9000 certified company, and recently we complete 10 year of ceremony in India. And over the 10th year of period, we installed more than 150 installation in India. Again, the benefit of providing palletizing system from 𝐒𝐭n India is like you are buying European quality with Indian price, as well as the technology from 𝐒𝐭n, the core technology is from 𝐒𝐭n Austria. We say patented die head designs, okay, the servo mechanisms and hydraulic mechanisms. So we only import that part from 𝐒𝐭n Austria. Rest of the things we dryers, panels, and fabrication we are doing in India. So we have young dynamic engineer teams to support you. We have in-house laboratory to invite our customers to bring your materials and took trials and see how easy it to operate. So we have two technical center. One is in Austria, another is in Econ India. And yesterday only, we had inaugurated our new lab line, that is a hybrid pelletizer. Hybrid pelletizer, as I said before, it's a combination of two pelletizer, air and water. Okay, EVA, we call EVA, Econ, water and air. Okay, so the top one is our Austria facilities, and the bottom one is our Indian facilities. So we invite our customers to, like, they are most welcome to come up with your materials and have a took trials and see the proven result based on your applications. These are our happy customers list. So might be you find your name also, our current customers, those who have. We serve industries, chemical industries, compounding and master batch, color master batch, recycling, research lab and universities, biopolymers, food and pharma, fluoropolymers, refinery, petrochemical, and hot melt adhesives. So these are the applications where we serve industries with our pelletizing systems. Some of example of our pellets, more or less this is related to the compounding field, but we have various experience of reference list, the trial and industry we serve. So we have the reference, lot of reference with the application we have. We have Econ underwater pelletizing systems, then air pelletizing systems, and hybrid one. You see the hybrid one is like water and air, the combinations. The only you have to change the cutting mechanisms, okay? Because for the water is a medium for the conveying the pellets, right? Where in air pelletizing system, the air is a medium to convey the pellets. This is our EWT, water treatment and drying systems. So this is the standard ones we have. Normally we supply with the equipments. Based on your applications and based on your requirements, we suggest if the contamination is high in the water and the application is very clean, then we recommend to the band filter. And again, the next one is water filtration professional EWTP. So this is application. So based on your application, we design the pelletizing needs. Now we come up to the lab line we have. So first one is EVA, and the second one is, first one is EUP, and the second one is EVA, hybrid one. So we take a pride to that we are having such kind of small equipment for your lab center. It's a tabletop machines. Maybe your table is bigger than this. Now we come up to the next about our products we have. We also provide a screen changer, manual screen changer, as well as discontinuous screen changers. And this is a continuous screen changer and continuous screen changer with backflash systems. This is again a beauty product for cleaning of your process elements like breaker plate, die head, and screw element, or the entire screw. So these two products we have. For the standard application, we having this one, the first one, and the screw elements or screws, we have the another one. Again, as we serve various industries, so looking to the master batch applications, we know the pain of master batch industries manufacturers. The cleaning is the toughest part ever in the industries. So this is 𝐸CON EWT for the master batch additions, wherein we have rotors, screens, and body segmented. You can remove it entire screens, you can remove it entire rotor and clean it and refit it. So it's easy to handle and easy to manage. So no more headache for your cleanings. So you are having the full access of cleaning of your equipments. The other one is the PAT additions with crystallizations. We have hot melt applications, then 𝐸CON vibration drying systems for removing moistures. It is also, we can use as a pelletizing part or standalone. Based on your application, we can suggest you the right solution on that. This is the model we have for EUP10, where you can produce 1 kg to 30 kg, and EUP8000, the highest one, having the capacity up to 8 ton to 15 tons per hour. So we always provide a full solution to customers. Like if we are talking about the diverter valve is the standard scope of supply for our industries. And you see the servo mechanisms, knife force. Servo mechanism knife force is basically a standard one, where in the industries we have two kind of arrangement. One is spring loading mechanism for applied the force on the die plate, and the second one is pneumatic. So we believe in proven technology, so we provide servo mechanism as a standard scope of supply, not the optional one. So you will get a proven machines with full scope. This is a small video about our pelletizing technology. This is the whole unit we are talking about as assembly. Diverter valve, cutting chamber, control cabinet, die head unit, and the water tank and drying system. The pelletizer unit is on wheel, so it is easy to remove while you are having maintenance on screw or your extruder part. So your pelletizer will connect to the diverter valve. Your extruder will connect to the diverter valve. After purging through diverter valve, you directly goes to the die. So you will easily have access of die. Once material purging out from the die, you have the only that manual function to do to operate the system. After this, you close it, and the single push button starting with the locking system, knife advancement, and the process water. The whole system will start automatically. The moment, this is the inside view of die head with the segmented die head design. And this is our patented thermal insulation technology, which provide you a versatile range of process applications. Once the molten polymer coming out through the die, the knife will immediately cut and wipe out to the water will carry to dryers. This is the additional attachment we call agglomerator catchers. If some lumps forms during the startup, it directly collect in the separate bin. So that lumps will not go to the end pellet and dryers. And the 95% of water directly goes to the tank rather than to go to the dryers. So that means you have the less moisture at your end pellets. Defined air stream for the best drying systems. Now you have the final pellets from the dryers. This is the add-on equipment for the band filter. So you see like the water coming out from the dryers, so band filter will filter the water and conveying the contaminated and collect through the collecting bin. And this is also a automatic functionality. We have the sensor, we have the equipment. Once they automatically sense the system, then it change it. Now we come to the points about the thermal insulations and how we stand out from our competitor. Okay. You see, this is the result from university we had done from our competitor, and this is from 𝐸CON. So you see, the nozzles we have, the yellow mark is the molten polymers passing through the nozzles, okay? And the blue parts is cover is the die plate unit we have, and the red part is the die head body. So it is a general phenomena when the hot parts comes in the contact with the cold part, the heat got transfer either sides. So this is not happen in our because of the thermal insulation technology. Hole not freezing because of this technology. And you have the constant melt temperature at the melt carrying barrier nozzles. And this is the how results we optimize. 𝐸CON, because of the thermal insulations technology, the on-off time for the heating is only 5%. Where is other applications? It's 60%. That means over the period of time, the efficiencies of heater is also reduced, and the saving in energy consumption is in front of you. You can see it. This is the EVT we are talking about, is the drying systems. In EVT, we have different kind of rotor solutions for base of your applications. If the application is abrasive, we have wear protections for our rotors, because it is the part directly comes in the contact with the end application. And we have other application for highly abrasive applications. We provide HVO coating for to protect the sieves and rotors against the abrasive applications. Again, we have solution for the non-sticking applications. So we do PTFE coatings for sticky applications. This is the agglomerator catcher we already have explained in the video. All this is a standard scope of supply in 𝐸CON. We have two pumps, one for the process water and the second one for the cooling. So cooling pump is always using to maintain your process water temperature. That is a necessary part of drying systems. Again, band filter is the application we already discussed. PHE is directly connect to the tanks. So maintain the temperature of your tanks by supplying your input water from the chiller or cooling towers. This is a process pump and cooling pump. Again, we have the different types of layout arrangement for your space requirements and application needs. If you have a space requirement, we can make a zigzag arrangement for your plant setup. This is a pyrolysis furnace is again demanding in the nowadays because the carbon emissions norms from the governments. So you can clean your process elements in this in a controlled temperature and vacuum environment. Maybe some technical glitch in video. It's okay. This is the application we have tested, a breaker plate with a lot of polymers over here. And the next is after the trials in furnace. So you see that chamber of the elements is put into the chambers, and the bottom is the collecting tank and condensing tanks, and the red one is activated carbon tanks and vacuum pumps. So econ pyrolysis furnace benefit you the gentle cleaning of your components without any external cooling force. So the temperature is controlled and the process is happened in the vacuum chamber. That means there is no oxidations with your metal components. You enhance the life of your components. And the cycle is like up to 7 to 8 hours. So the cooling process is natural coolings. After the first cycle of cooling temperatures first to molten your polymers and then degrade in the second cycle, and cooling in this process is happening naturally. This is again example for the EPO-S for the standard version for screw, dedicated line for we provide you. So again, you can have comparison before and after. As I discussed before, this is the master batch additions. We have the segmented screens, rotors, and tops. So it handle easily to clean your parts. This is the PET recycling application. We have PET additions, wherein we have the control temperature and we insulated our water tank to maintain the temperature, because this is the basic requirement of PET additions to maintain your process temperature to achieve the crystallizations. In our this we are able to achieve 30 to 40% of degree of crystallizations because of the thermal technology we have and the insulation water tank. Now we come to our 𝐒𝐞𝐭𝐢𝐯. It's a fully automatic Pelletizing systems we have. 𝐒𝐞 is a combination of thermal insulations technology and the industries 4.0, and it is an integrated robot systems take over the usual operations. So this you can operate from your home also. So remote access is possible in that situations, and one operator can operate 10 lines. This is a small video. This is a fully automatic, like you can check. The robot is accessed first the cutting arms and select the right one to place into the cutting chamber. No man required or no operator required. This is entire process is going to happen automatically. Okay. So, yeah, we have a dedicated service teams to serve our customers. We have online support module in the machines for your necessary breakdown, to avoid any necessary breakdowns regarding to your program and PLC. And we maintain spare part management in India to emergency support your any kind of breakdowns. So our headquarters is based in Austria, close to Linz. We have facilities in India, Vadodara. We have facilities in Econ, USA, as well as China. And we have a lot of channel partner for our, you see in the map. So thank you for your kind attention. Thank you so much.
Thank you so much, sir, for your valuable expertise. So for our final session, if anyone has any questions, kindly ask.
Ram sir.
Yes, sir.
It is possible to install band filter in our existing machine dryer?
No, because for that we have to change the entire tank assembly.
Oh.
Modification is possible in dryer. We can uplift the height, okay? But tank, water tank assembly, we have to modify it.
Required modification.
Required modification. Attachment in existing system is not possible because of the size limitations. But rest of the things like dryer height, we have to replace only the tank body.
Tank only.
Tank body with the band filter.
Okay.
Mr. Ram, Episa this side. Yeah, I have one simple question. You have shown very lucrative energy saving in your machines.
Yes.
Fine. How it stands on fixed cost or the investment for this machine, comparatively?
Sir, I can guarantee you, if you compare a heating load connecting my systems with the competitor, you must have some machine at your shop floor.
No. We saw your figures, we believe your figures, but that shows very lucrative figures.
Yes.
So what will be ROI if we go for your machine? Roughly you can say 4x, 5x, whatever it is.
the principle of econs, we always committed a fixed figure. Okay. So if you have any concerns, you please share your data.
Sure.
Then we will work on it and we will deliver you.
Okay, thank you.
Is anyone left with any questions? Yes, sir. Sir, one more question.
Hello. 𝐿 have provided servicing for the screw shaft cleaning in pyrolysis furnace. Hello.
Yes.
𝐿 is providing screw shafts cleaning service at in pyrolysis at port.
We don't have any pyrolysis furnace for screen as of now in our lab center, but we had provided to our customers. Okay, so we have the pyrolysis for your kind of applications, and it is customized, totally customized based on your screw length. We can design it.
You are not providing servicing. You are not providing service.
No.
Okay.
We are selling equipment.
It is very costly.
We can work out best deal for you. Please float your inquiry.
Thank you so much, sir. Is that anyone left for the questions? Okay, thank you so much. So finally, we arrive at the one of the most prideful moments of our event. It is with a great pleasure that I announce a special occasion where we honor our esteemed experts for their exceptional contribution. To present this token of appreciation, I would like to invite our team members on the stage. Now, to present our first honor, I would like to invite Mr. 𝐻𝐶 on the stage. India Limited for receiving the token of appreciation. Let's give them a big round of applause. Thank you so much, both of you. Now we move on to our next souvenir. I would like to invite Mr. 𝐻𝐶 on the stage to present the certificate. The souvenir goes to Kubota Brabender Technologies. May I kindly request Mr. Anup Biswas and Mr. Yagnaraman to come forward and join us on the stage. Please give them a big round of applause. Thank you so much. Now I would like to invite Mr. 𝐻𝐿 on the stage to present the next participant certificate. This certificate goes to 𝐒𝐗. May I kindly request Mr. Andreas Bacchus to join us on the stage. Let's give them a big round of applause. Thank you so much, sir. For the next honor, I would like to invite Mr. 𝐻𝐿 on the stage to present the souvenir. This appreciation presented to X compound. May I kindly request Dr. 𝐒𝐻𝐿 to come forward and join us on the stage. Let's give them a big round of applause, everyone. Thank you so much, sir. For our next participant certificate, I would like to invite Mr. Lokesh Sharma on the stage. This certificate is presented to the Japan Steel Work Limited. May I kindly request Mr. Takeharu Kato and Mr. Hiroki Sintani to come and join us on the stage. Let's give them a big round of applause, everyone. So for the final souvenir of the evening, I would like to invite Ms. Sweta Waghela on the stage. This token of appreciation is presented to Econ Machinery Private Limited. May I kindly request to Mr. Ram to applause to conclude our recognition and presentation. Thank you so much, sir. So for the first name is Neeraj Mehta. Please give him a big round of applause, everyone. So congratulations to our 3 lucky winners. So now, I would like to say thank you to everyone for joining us on this special occasion and celebration. It's nearly impossible to have a successful event without the support of many hands. As an audience, we tend to focus only on the movie, only on the actors when watching any movie. But every members of the crew play a close. It's time to reflect on the valuable insight we have gained throughout the day. To provide our final thoughts and wrap up the discussion, I am honored to invite Mr. Vinu Chawla to deliver the closing remarks. Please give him a big round of applause.
Namaskar, everybody. I'll not take much of your time because we already passed the timeline. 7:30 was the timeline. We are crossing 8 now, so I'll take only a couple of minutes. I would like to thank you, the spark of the event. I need to say Takeharu-san. Yeah. So he's the guy. He started that we should make an event in India like this. So, and our partner 𝐒𝐞𝐬𝐬𝐢𝐶 and 𝐻-Compound, 2 hands of my success. So, this is big thanks to 𝐒𝐞𝐬𝐬𝐢𝐶 and 𝐻-Compound team altogether. So this is about the partners, and I should not forget my team who worked day and night since last 4 weeks, primarily Sweta Waghela. Thank you so much. And the team who joined in Lokesh Sharma, Harsh Rana, Hari Rami, Haribhai Lalani, Harshil Darji, of course, 𝐿𝐻𝐿, and I have only contributed 1%, so I should not say thank you to me. And team of Vrunda, Shivani, Neha, Mayur, all together.
Thank you, sir, for your kind words, and thank you so much to all. Thank you so much to all of you for your enthusiastic participation in today's technical session.